Hey guys, Daniel here. Hope you guys are doing well, and welcome to my predicted paper 3 for your stats and mechanics exam on the 19th of June. Guys, that feels so good to say this is my last predicted paper of the academic year. So I'm excited for you guys to finally have it. Today is Saturday. I said I was going to get it out. If any of you guys have me on socials, you would have seen my story today. I've got it out, so I'm so happy. Yeah. What do I need to say about this paper? So this paper was actually based on a document that I created, and it's called a past paper topic breakdown of the stats and mechanics papers. I've done a video on it, and I've also got a document to this on my website as well. I'll have it in the comments. I'll have it in my description, and you can basically see how I created this paper. What else is there? There are 13 questions. There are 123 marks. So you get 2 hours and 30 for this one. But don't worry, there's lots of one markers, so it won't take you too long. I think you guys should be okay. Yeah, as always, the link to this paper will be pinned in the comments. It will be in the description. It's on my website, mathswithdan.com. Just go to Predict Papers, you can't miss it. Anything else I need to say? Yeah, I think that's it. Oh yeah, of course. If you stumble across this video first and you haven't done the paper, then please try the paper first and then come back to the video. I don't think there's anything else I need to say other than good luck with the paper, and let's get into the walkthrough. Okay, so question one says Oluwase Temi is the head of maths at a sixth form in London. She investigates whether there is a relationship between students' punctuality and their performance in a maths test taken that week. The number of minutes each student arrived late and their test score out of 50 are shown below for 8 students. So we've got the students, A to H, we've got X for the lateness in minutes and Y the test score out of 50. Let X represent the number of minutes late and Y the test score. Part A says we need to calculate the product moment correlation coefficient between X and Y for 1 mark. So this is just calculator work, isn't it? So what I'm going to do is get my calculator. Then I'm going to go to menu. I'm going to go to number 6, isn't it? Statistics. And I'm going to go to number 2, y is equal to a plus bx. And I'm going to put these values in. So it's going to be 0, 5. This is for x's. 3, 2, 7, 10, 6, and 1. All right. And then for y's, it's going to be 45, 38, 40, 42, 36, 30, 35, 44, like that. So now I've got my values for X and Y. I'm going to click option now and I'm going to go to number 4 for regression calculation. And that will give me the regression line, the A, B, and R, isn't it? Right? So R is what I'm looking for, the product moment correlation coefficient, and that's minus 0.989 to 3 significant figures, isn't it? So I'm just going to say for part A is going to be R is equal to minus 0.989. Perfect. Part B. It says state in your hypotheses clearly and using a 5% level of significance. Test whether or not the correlation between lateness and test score is negative. This is a 3 marker. Okay, so it's just a standard hypothesis test. So what you're going to do is firstly mark out your null and alternative hypothesis. So H0 and H1. Now rho in this case is always equal to 0. We're testing for negative correlation. So we're going to say rho in this case is going to be less than 0, isn't it? Now, what you want to do is obviously you're going to have your formula booklets in the table in your exam, aren't you? So you're going to go to your formula book here. And obviously what you want to do is calculate the critical value, right? The significance level is 5%, 0.05. And the sample size is 8, isn't it? Because there are 8 students. So I've just got this here. This is just from the Edexcel website. So we've got the table here. And obviously critical values for correlation coefficients. It gives the positive ones. But remember, it's the same thing on the other side. So all I'm going to do, when I say saving on the other side, I mean for the negative ones, you just put a minus on. So we need 5%, which is right there. And we need a sample size of 8, which is right there, which tells me it's this value, which is what I'm looking for. So 0.621. But remember, it's for negative, so it's going to be minus 0.6215. So what you can just say is maybe an exam from tables, the critical value is equal to minus 0.6215, isn't it? Let me just double check that again. Yeah, that's perfect. So what you do here is you always compare this value with your actual product moment correlation coefficient, right? And what we can say is that minus 0.989 is less than that, isn't it? Right? So the way I always remember it is that you always want it to be closer to your endpoint, which is -1 in this case, right? So what do you do here? So I put a 6, should be a 5. What do you do here? Since it's less than, this means that we reject H0, isn't it? So I always write this: reject H0, accept H1. And then what you want to do is you want to contextualize it to get the mark. So what does that actually mean? Well, we're rejecting H0, which said that there's no correlation, and we're accepting the alternative, which is there is a negative correlation. So all you're going to say now is this is statistically, make sure my handwriting is neat, statistically significant. So statistically significant. There is evidence. Whoops. There is evidence. So that's an I, yeah? There is evidence of a negative correlation between lateness and test scores. Perfect. Okay. Brilliant. So that's done. So that's part B. Part C. What does part C say? It says, suggest a possible reason for this correlation. Well, what is the correlation? Negative correlation. The later you are, the lower your test score. Maybe you don't have enough time when you get to class, right? That could have an effect on it. So you could just say, remember, it's these one markers that nobody really likes, isn't it? But just try and use the context and just think of something that is remotely plausible, right? So the student most likely is unable to complete the test due to being late, right? Or also they could be unserious, right? If you're an unserious candidate, you're going to be showing up late, aren't you? So maybe you're not revising as much. Something that makes sense due to being late. Okay. Whoops, doesn't look good. Let me do it again. Okay, perfect. So that's done. Part D. What I'm gonna do, just because we don't need to, just so we don't keep going up and down, I'm gonna grab this here. This is from part D, isn't it? So we do it here. Okay, it says Oluwasitemi suggests that a linear regression model could be used to model this relationship. State, given a reason, whether or not the correlation coefficient is consistent with Oluwasitemi's suggestion. I would say it's most definitely consistent. So I'm going to say consistent, consistent as R, which is minus 0.989, what we got in part A, is very close to -1, right? Which suggests a strong negative correlation. Yeah, something along those lines. So you just want to compare your value of R with -1, right? Is it close? Looks close. Yeah, so it's good. So part E, it's a state given a reason which variable would be the explanatory variable. So part E, what would be the explanatory variable? Well, it would be the lateness, isn't it? Right? So you'd say lateness would be the explanatory variable, the variable that explains the dependent one. Would be the explanatory variable as the test score will depend on how late you are, how punctual you are, right? Depend on how punctual you are, something like that. Okay. Now that's part E. Part F. It says Oluwasitemi calculated the linear regression equation as y is equal to 45.03 minus 1.48x. Part F says explain why Oluwasitemi's regression model might not be appropriate for students who arrive more than 31 minutes late. Well, what is this regression model for? Remember, y is your test score. Y is your test score. Oh wait, I've done it here, isn't it? Let me just get rid of this. That's an extra one. Y is test score. and X is lateness, right? Put this here. X is lateness, right? Now remember the regression model is Y equals 40, what was it again? 45.03. 03 minus 1.48x. Yeah? Well, what I would do is plug in 31 minutes, which is X, right? X is 31. Remember, it's explain why it might not be appropriate for a student to arrive more than 31 minutes late. Well, if I plug in X equals 31, what test score do we get? Let's try it. So I'm gonna go do I click on again? I'm trying to get to the calculation. Okay, go there and I'm gonna plug this. It's gonna be 45.03 minus 1.48. Just make sure you can see it. Times by 31, right? We get that number there, which is minus 0.85, right? You can't have a negative test score, right? This is less than zero, which is impossible. Uh, so I'm gonna say this is impossible as you cannot have a negative test score. Negative test score. There's a lot of writing in this question. Score. My handwriting is actually neat in this. It's just hard with this tablet thingy. But yeah, that's it. And that will give you all of the marks in question one. Fantastic. So yeah, let's go to question two now. Okay, so question two says a researcher is studying the birth weights of babies. A random sample of 98 babies was taken and their birth weights, W kilograms, are summarized in the table below. So we've got the birth weights on the left, we've got the frequencies in the middle, and then the birth weight midpoints on the right. You may use these summary statistics there, and it says a histogram is drawn to represent these data. The bar representing the birth weight 1.5, so the weight between 1.5 and 2.5, has a width of 1 centimeter and the height of 4 centimeters. Part A says calculate the width and height of the bar representing birth weight between 3.5 and 4. This is 3 marks. Now, firstly, when you see histograms, I always even tell my GCSE students, just remember the area of a bar is equal to the frequency. So what we want to do is figure out the dimensions. Obviously, that's what they're asking us to do. But we can do that with this information given. And I always visualize these, you know. So let me just zoom out a little bit. Whoops. Let me zoom out a little bit so I can draw a bar. So the information I do know is this one here. So I'm going to visualize this. So I'm going to draw a rectangle like that. And what do I know? I know that the bar representing the birth weight of 1.5 to 2.5, right, has a width of 1 centimeter like that, and a height of 4 centimeters. Now, has a width of 1.5 to 2.5. So I'm going to write this here. So this is going to be the width, 1.5, and that's going to be 2.5. Now, remember, the width here is in kilograms. So straight away, I can figure out the relationship between centimeters and kilograms, right? 1 centimeter, right, is going to equal the width from 1.5 to 2.5, which is going to be 1, right? So 1 centimeter is 1 kilogram. Now, remember what I told you? The area is always equal to the frequency. I mean, I didn't tell you that. You guys know that anyway. But yeah, how can we use that to help us? Well, we know the frequencies of each of the intervals. It's given here, right? Now, the frequency of the one that we're looking at, 1.5 to 2.5, there's a number at the top is 16. So what I can say is that the area, right, must correspond to 16 babies, isn't it? Yeah? So I'm going to say 16 babies here, like that. Now, why is this helpful? Because I have the rectangle. They've given us the dimensions of the rectangle, right? So the area of this one is just going to be 4 times 1, which is 4 centimeters squared. And then now remember, since the area represents the frequencies, I can say that the 4 centimeters squared is equal to the 16 babies. I'll just write 16 for now. And this is extremely powerful because now that will allow me to convert any frequency into an area, right? So, what I'm going to do is say, well, 4 centimeters squared is 16. That would mean that 1 centimeter squared is equal to just 4. We just divide both sides by 4. Now, what are we trying to calculate? Remember, it says calculate the width and height of the bar representing birth weight of 3.5 to 4. Right? Now, there's a couple of things here. Let's get another diagram. I love a diagram, don't I? So for that one, the one we're actually trying to calculate, well, remember, we worked out the relationship between the widths, right? 1 centimeter is 1 kilogram. Now, the bar that we want, 3.5 to 4, right? Let's just say that's there, 3.5 in kg, 4 is over there. Now, what is this in centimeters? Well, if 1 centimeter, right, is 1 kg, and this is in kg, like that, well, then the width of it is just 0.5 kg, right? So I know that this is 0.5 kg from there, right? 3.5 to 4 kg is 0.5. And what is this in centimeters? Well, this should be the same, isn't it? 0.5 centimeters. So now that part is done, right? The width is going to equal 0.5 centimeters. Now, how do we calculate the height, right? Well, remember what we said, we can convert any frequency into an area, can't we? So we know that 1 centimeter squared is 4 units, right? Or 4 babies. And we know the frequency, luckily, for the one that we're trying to calculate, 3.5 to 4 is 14. Yeah. So what I'm going to say for this one here is for this one, the frequency is equal to 14 from the table. Now we want to calculate what this is in areas, right? So what I'm going to do is I'm going to say that, well, if 1 centimeter is equal to 4 units, then what would 14 units be, right? All we're going to do is how many fours go into 14? Put this there. The question mark is going to be 14 divided by 4, right? Which is 7 over 2, which is equal to 3.5. So therefore, the area, right? This area here has to be 3.5 centimeters squared for sure. So now what can we do here? Well, let me just get this diagram again. That. And what we can do then is say, well, remember, we're looking for the width and height. We know that the width was 0.5 centimeters. Well, what is the height? Well, we know the area, we know the width. It's going to be 0.5 times h is equal to 3.5, like that. And this is just half of h, isn't it? So therefore, h is just times both sides by 2. H is going to equal 7. So therefore, the dimensions are the width is equal to 0.5. And the height, yeah, the height is 7. Let me write it like that. Height is equal to 7 centimeters. And that's it. Finished. Okay, so part B says use linear interpolation to estimate the lower quartile of the birth weights of the 98 babies, and this is just 2 marks. All right, so lower quartile, right? Firstly, that's going to be a quarter of the data, so I'm going to divide the 98 by 4. So 98 divided by 4 is 49 over 2, which is 24 and a bit, isn't it? It's 24.5. So it's the 24.5th data point, right? Now, when you're doing linear interpolation, remember you're assuming that the width, right, the class widths are evenly distributed, right? And you want to just ask yourself, how far, you want to estimate how far inside the interval are you, right? Now, what we'd want to do first is figure out which interval this 24.5 data point lies, right? And how do you do that? Well, if you look at it, think of it as a cumulative frequency. This 16 here, 1.5 to 2.5, are the first 16 data points, or the first 16 babies in this case. So it can't be in there. The next part, well, it's going to be 16 plus the 24, which is going to be 40, right? So 24.5 is obviously less than 40, so it's going to lie in this interval here. And what you want to do, there's 2 ways to do it. I'll show you both ways, and you guys can let me know how you guys do it in the comments. So I'm going to visualize this, right? So I'm going to get, I don't need to do that, to be fair. I'm going to get a line like this, like that. And what I'm going to do, you know what, I actually get a nice line, just so it looks somewhat neat. Yeah. Okay. So what I'm going to do is I'm going to call the top the width, right? And I'm going to call the bottom the frequency. Now, the width, remember, we know that it lies where the 24 is, which is going to be 2.5 to 3, like that there. And now the frequency, remember, it's cumulative. The lower bound is going to be the ending of the first one, the ending of the first interval, which is going to be 16. And the upper bound is going to be 16 to 24, which is 40. Right? Now we're trying to find an estimate for the lower quartile of the birth weights, right? Now we know that it's the 24.5th data point. Where would that be along here? It would be closer to 16, would it? Let's just say it's like around there. 24.5th data point. Like that. Now, what I'm trying to figure out is what value of W corresponds to that data point there. So how do we do this? Now, again, you're just using the fact that it's evenly distributed, right? So what you want to do, I'll show you 2 ways. You want to figure out, right, the difference between this one, right? And you want to figure out what fraction of this yellow width are you out of the entire thing. And then think of this as like a mirror at the bottom. It's going to be the same, right? So it's literally going to be like this, like that, like that. We're assuming it's evenly distributed, so it's going to be the same, right? So the proportions will be the same top and bottom. So what you're going to do is you're going to equate the proportions of the yellow width out of the blue, right? So all you're going to do is you're going to just do this. You're going to do W, which is what you're looking for, minus 2.5. That's the yellow thing. Out of the blue, which is 3 minus 2.5, which is 0.5. And this has to be equal to, because we're assuming it's evenly distributed the same, it's going to be 24.5 minus 16 over 40 minus 16, right? And then you're just solving for W. So let's do that and see what we get. So what's that going to be? W minus 2.5 over 0.5. And this is going to equal 24 take away 16 is 8. So 24.5 take away 16 is going to be 8.5. And then 40 take away 16 is 24, isn't it? So therefore, the width, right, for the lower quartile is going to be W times by that 0.5, which is going to be 8.5 over 24, right? Times by the 0.5. And then we're going to add on this 2.5, isn't it? Right? And that is our answer. Let's actually work out what that is first, and I'll show you the other way, which is literally the thing at the bottom. So it's going to be 2.5 plus 8.5 over 24 times by 0.5. What is that equal to? So that there, that's fine. That's going to equal 2.677, isn't it? So to three significant figures, it's going to be 2.68, isn't it? 2.68 to 3SF. Is that correct? 2.68. Perfect. Perfect. So that is the actual answer. Did it give us a degree of accuracy? No, it didn't. So we'll leave it to there. Now, the other way of doing it is just literally kind of memorizing this formula. Yeah. So all you're going to do is you're going to ask yourself, okay, remember this diagram helps. You want to ask yourself how far you are into this, right? Into this interval width 2.5 to 3. So you know that the beginning of it, right, is going to be 2.5 like that, which would go there. So 2.5 will go there plus, right, the fraction of how far you go inside, because remember we're assuming it's the same, right? 16 to 24.5 is 8.5, right? The yellow thing which goes there, and then dividing by the entire thing, which is 24, and then you just times by 0.5, right? So it's literally the same thing. 0.5 coming from the 2.5 to 3. What I'll do is I'll actually put a graphic here, because I taught this actually not too long ago, right? And there's like a formula that you can use to memorize this. But yeah, I'll put it now so you can see it, and then you can stop it. And then yeah, you guys let me know which method you guys prefer. Do you prefer the formula way, or you prefer the way that I did at the start? But yeah, that's it. So that one's done. Let's go to the last part, right? Part C. It says, find an estimate for the mean birth weight and the standard deviation of the birth weights for 3 marks. Now, with this one, this I think is the easiest part of the question. This is where this part comes into it, isn't it? Right? So I'm going to put this here. And then what are we looking for? We're looking for the mean and the standard deviation. So let's do that there. So this part here. So remember, to calculate the mean, right, when you're dealing with group data, it's just going to be the sum of it divided by the amount, right? That's not hard at all, to be fair. So the mean, I write W hat for it, is going to equal the sum of fx divided by n, right? Which in our case, the sum of fx is going to be 311.5, and then n is 98. So it's going to be whatever this is equal to. So I put this in my calculator to see what I get. It's going to be 311.5 over 98. This is equal to 89 over 28, which is 3.18, isn't it? Right? 3.18 to 3SF. Now, the standard deviation, right, which is sigma, right, is equal to the square root of the variance, right? And always, what is it? It's the mean of the squares. So mean of the squares, like that, minus the square of the mean. As long as you remember that, you're good. I'm pretty sure this is in the formula booklet as well. Like right there. So you're just going to plug in everything that we know here. So the sum of fx all squared is going to be 1051.125 over n, which is 98, minus the mean of the squares, which is that number there. But what I would do is I would just put this one here, 89 over 28. Or you know what, just to be super clear, I'll put that one in just so it's super clear, like that, squared. So now I'm gonna work this one out here. So it's gonna be equal to okay. Oops, I forgot the fraction bar, my bad. So gonna do that now. It's gonna be I've got that number stored, so I'm not gonna write it again. It's gonna be square root 1051.125 over 98 minus the mean squared, isn't it? Like that. And that gives us that number there, which is going to be 0.7, what's that? 89 to 3SF. And yeah, that would be it. That is the entirety of question 2 finished. Let me just double check I've written this all correctly. Yep, looks good to me. Yeah, finished. Okay, so question 3. It says, in a large population, 40% of adults use online banking. A random sample of 50 adults is taken. The random variable X represents the number of adults in the sample that use online banking. Part A says, for part I, find the probability of X equaling 26. So quite clearly, we've got a fixed sample size. We've got a fixed probability. This is a binomial distribution. So first, I'm going to write out what the binomial distribution will be. Be binomially distributed with N, which is going to be 50. And 40% use online banking, so P is going to be 0.4. And they're asking us for this one here. So this is just calculator work, isn't it? So I'll put this in the calculator and see what I get. This one's going to be menu and then 7 binomial PD because it's a point. Variable X is 26, N is 50, and P is 0.4. So that is just going to equal 0.025, and what's the last one? 259 to 3 significant figures. Okay, that's fine. Part double I, it says find the probability of X being greater than or equal to 26 for 2 marks. Okay, so remember, X is greater than or equal to 26. I think you can do this with that fancy calculator. Is it the CG50 it's called? Straight away. But yeah, if you don't have that, then remember, well, this is going to be, you can just draw a diagram to see it, right? If I want more than 26, 27, blah, 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 all the way up until 50, I want this part here. Then I'll have to take away everything before that, which is 25 and below. Yeah? 1 minus, isn't it? So we're going to say then that this is just going to equal 1 minus the probability of X being less than or equal to 25. And this we can calculate with the calculator I have. So I'm going to just do, how do I click equals, right? And then I need to go to CD now, don't I? Because I'm dealing with a cumulative. So I'm going to go down. I'm going to go to 1, 2 variable, and I'm going to change that 26 to a 25, aren't I? So I get that number there, which is that. So it's going to be 1 minus 0. And what was that? 942, blah, blah, blah. 9426, isn't it? Yeah. I bet I'm just going to calculate this. So click equals, it's going to be 1, and then it's going to be 1 minus answer. Oh, hold on, let me just check it's stored. Yep, it's stored. 1 minus answer is going to equal 0.057. And what's the last one? 3. To 3 significant figures. So that's double I. Triple I. Find the smallest value of k such that the probability of X is less than or equal to k is greater than 0.4. So again, this is just guesswork again, isn't it? This is just, you can even use the tables as well. Does anyone still use the tables? I wonder. I think it's a bit obsolete. Anyways, so I want to figure out the value of k, which will make this more than 0.4, the first value, isn't it? Right? So if I go back to 7, distribution, and then binomial CD, which is 1, 2 variable, I want to figure out, I know what the N and P are. N is 50, P is 0.4. I want to figure out a value that will the first value that will make this more than 0.4. So for example, let's say I start with 15. What do I get? This is less than or equal to, isn't it, right? So this is going to be, this number is less than 0.4. So let's just try 20, for example. Oh, that's more than 0.4, isn't it? So let's go down by 1. So is that 1? 0.446 is more than 0.4. Is that the first value? Let's try 18. This is less than 0.4. So the first value for k for which that happens is at 19, doesn't it? Yeah. So therefore, just literally k is equal to 19. Perfect. So that's part A. Now, what does part B say? It says a random sample of 600 adults is taken. I says find, using a normal approximation, the probability that no more than 222 of these 600 adults use online banking. Okay, so let's have a go at this one. So remember, if you're using a normal approximation, remember your two formulas, right? So remember, for normal approximations, mu is going to equal NP, and sigma, the standard deviation, is going to be NP, the square root of it, 1 minus P. Yeah. So in our case, what do we have here? Well, remember, well, n in this case is going to be 600, right? Because a random sample of 600. The probability from the binomial, I believe, was 0.4. Let me just check. Yes, 40%. Yeah. So I'm going to use these values of n and p to figure out what my corresponding values of mu and sigma are going to be in my normal approximation. So I'm going to plug these in. So mu is going to equal 600 times 0.4, which is going to equal 6 times 4 is 24, probably 240. 600, yes, 240 anyway, but let me just put in 600 times zero point 0.4 is 240. So that's 240 there. And then sigma is going to equal NP. N times P is this thing here, it's just 240. And then 1 minus P, which is 0.4. So it's the square root of 240 times by 0.6, isn't it? So I'll put it in and see what we get. Square root of 240 times 0.6. This is equal to 12. Okay. So in our normal approximation, right, what we're saying here, let's just use another random variable. Let's say y. We're going to say it's going to be normally distributed with a mean of 240 and a variance of 12 squared, isn't it, right? And this here, we're meant to be approximating this binomial distribution, isn't it? Yeah. So which was 600 and 0.4. Okay. So what did the question ask us to do? It asked us to calculate the probability that no more than 222 of these 600 adults use online banking. Yeah. So what is that going to be in terms of the binomial distribution? It's going to be the probability of no more than 222 means 222 is the highest number. So it's going to be less than or equal to 222. And what we want to ask ourselves is, well, what would that be in terms of our normal approximation? Now, remember, when you're dealing with this is discrete, normal's continuous, you have to apply a continuity correction, right? So probability of y, right, is going to be less than. Now, to get your continuity correction, ask yourself, what can this number round to? What's the upper bound of this number that it can approximate to? It's just going to be 222.5, isn't it? Yeah. So yeah, you're gonna just literally calculate this here with this information here. So all this is now is just calculate work from here. So it's going to be 7 is there. Normal seed is what I'm looking for. My lower bound is going to be at the very end. Minus 10 to the 10. I always just choose that number there. You can just spam it with zeros as well if you want. 222.5 was my upper bound. The standard deviation is 12, isn't it? And the mean is 240. And this is equal to 0.0, what is that to three significant figures? 724, 724, 724 to three significant figures. And that is our answer. Now, there was a lot. Next one, explain why, double I, explain why a normal approximation is suitable in part BI. Well, what are the requirements for a normal approximation? N has to be large and P has to be close to 0.5. Yeah. So for this one, what you're going to say is N is large and P is close to 0.5. Yeah. N was 600, P was 0.4. Yeah. Perfect. And that is it. That is question 3 finished. Okay, so question 4 says three events, A, B, and C, are such that the probability of A is equal to 0.1, the probability of B given A happens is equal to 0.3, the probability of A union B is 0.25, and the probability of C is equal to 0.5. Given that A and C are mutually exclusive, part A says we need to find the probability of A union C for 1 mark. So, part A, union. A and C are mutually exclusive. Immediately, that means that they're disjoint. There is no intersection. So that's what I'm going to write first. Probability of A intersection C has to be 0 if they are mutually exclusive. And then now what is the formula for A union C? It's probability of A union C is equal to the probability of A plus the probability of C minus the probability of them intersecting, because you'll count them twice, wouldn't you? So we've got that there. Now, what do we know? Probability of A is 0.1. Probability of C is 0.5. And that there is 0. So that's just 0.1 plus 0.5, which is 0.6. So that is part A. Part B says show that probability of B is equal to 0.18, and that is for 3 marks. Now, B. What do I know about B? Well, if I look along here, I've got this conditional probability, which is something that we're probably going to use. So, B. Now, we just show it's 18. What I do know from the question is that the probability of B given that A happens, right, is equal to 0. What was it? 3. Right? Now, this is a conditional probability, which is in the formula book, I believe, but I think there's different variations of it. But the one that I use is the probability of A given that B happens, right? Or it must be the intersection of both of them, A intersection B, and it will be out of B, isn't it? Right? That is the formula. Now, the other way is going to be the probability of B and A intersection, which is the exact same thing, but I'm going to write it this way just for consistency. And it's going to be out of the probability of A happening. So, what do we know? Well, we can calculate the intersection, can't we? Because of the fact, what do we know? That there we know, that's 0.3 on the left. This is equal to probability of A was, what was A again? 0.1. 0.1, and this is the probability of A intersection B. So we can calculate that there, or B intersection A, same thing. Let me just do it this way because it's consistent, right? And then I'll just write B intersection A, and I'll write probability of B intersection A is the same as the probability of A intersection B, isn't these are the exact same thing. So what I'm going to do then is say then that 0.3 times 0.1 is going to equal the probability, and I'm going to use this one, yeah, A intersection B. Now what is that? That's just 0.3 divided by 10, isn't it? Which is going to be 0.03. This almost confused me, you know. Okay, so yeah, that is the intersection of A and B. Now we need to show that B is 0.18. So we've got the intersection, right? And we know what A is. So if they intersect, then we know the union. Oh yeah, this is easy. Yeah. So again, just use that formula, right? So we're going to use the formula for union, right? That's going to be probability of A union B, the one we used in part A, probability of A plus the probability of B minus the intersection of both of them. Now, what do we know? Union B is 0.25. Probability of A was 0.1. I can see that there. Probability of B is what we're trying to find. And the intersection we just calculated to be 0.03, isn't it? Yeah. So what's that? On the right hand side, that's 10 take away 3, which is 7. That's 0.07 now. Like that there. And then like that. And then that must mean that probability of B is going to equal 0.25 minus 0.07, which is 25 take away 7, which is 18. So it's 0.18 as required. Fantastic. Okay, so we've done that. Now, part C. It says, given also that B and C are independent, draw a Venn diagram to represent the events A, B, and C and the probabilities associated with each region for 5 marks. Okay, so let me get that. All right, so we're drawing a Venn diagram, right? There's a lot going on here. What I would do essentially is actually just grab everything that we do know about the probabilities, right, before I get going. So I'm going to grab these. So I know these for a fact. And what did we calculate in the other questions? We calculated that the probability of A union C was 0.6, and we showed that B is at 18. So A union C is equal to 0.6. The probability of B, sorry, is 0.18. And did we find intersection as well? We found the intersection of what again? Oh yeah, A and B, 0.03. So I would just put those in there. And I believe that is it in terms of the all of the things that we know. So we need to draw a Venn diagram. I remember, there is no intersection between A and C. So what I'm going to do is I'm going to draw a rectangle like that, and I'm going to draw three circles like that. So one, two, and then three like that. Let me make these bigger actually because they don't look big at all. Make it big like that. And then let me get this there. So I've got A, I've got B, I've got C like that. Now, what are we trying to calculate? We're trying to draw the Venn diagram. So what do we know? The intersection is there. That could be 0.03. That's fine. Anything else that we know? Um, well, if A is 0.1 altogether, then that has to add to make 0.1. That's going to be 0.07, isn't it? That's a given. What else do we know? We know the union of A and B is 0.25, so everything there and there is 0.25. Didn't we calculate something? I know they also told us this, didn't they? They told us that B and C are independent, so we could find out what the intersection. Okay, that's fine. So independence, right? Remember, if two events are independent, that's actually very good. The probability of B times the probability of C, right, is equal to the intersection, isn't it? Right? This is independence. Let me write that here. Independence. Okay, so what do we know? We know the probability of B is 0.18, like that, and the probability of C is 0.5, right? And that is the intersection. So that is very, very good news. That there, that's half of 18, that's 9, that's 0.09. That's how I work with decimals, to be honest, because otherwise my brain will just be frazzled. Is that correct? Let me just double check, because I'm imagining the way I make walkthroughs is like I'm in an exam. I need to make sure everything is on point. So I will put 1 plus 1 in if I have to. Perfect, perfect. So the intersection of B and C is there. So that's going to be 0.09 there. Hold on, that's like a, do that again. 0.09 like that. And then because we know what B is, we showed that in part B is 18. The thing in the middle here has to make 18. That's 3 plus a 9. That's 12. I need 18. I need a 6. That's going to be 0.06 there. And then C we know. C is 0.5. So if that's 0.09, 50 take away 9 is 41. Plus 0.41. Now we're not done. Just like I'm just thinking about my GCSE students. You're not done here. The outside, right? Do these all add to make one? If they do, then you're fine. But always check. They're not going to though. 0.07 plus 0.03 plus 0.06 plus 0.09 plus 0.41 is equal to 0.66, right? So therefore, the outside is going to equal 1 minus 0.66, isn't it? Which is 100 minus 66, which is 34. I nearly forgot the 0 point. Let me just do 1 minus answer. Yeah, perfect. So that is the complete Venn diagram. So you could have done it that way. Another way you could have done it is just doing a three-way Venn diagram as well. So if I was to do that, then it would be like you do that, and then like there, like that there, and then if I do three circles like that, whoops, need intershape, don't I? I'll do three circles like that. No, that's not a circle. Sorry, guys. Circle, circle, and then another circle like that, and then A, B, and C. And then you could have done it like this, right? And then obviously, because A and C are disjoint, then this has to be a 0 and that has to be a 0. The intersection of B and C was 0.09, so that would go there. That's going to be 0. No, sorry. That is that's B, isn't it? So let me do that there. And that didn't change. That should be a B. So yeah, that's fine. Outer part of C is 0.41. That would go there. And then what do I know? Well, I know that the outer part of this one here, the intersection of A and B is 0.03. This is 0.07, and that has to be 0.06. So you could have done it that way as well. To be honest, let me just make sure that's all good. Yeah, that looks good to me. There's no intersection with A and C, even though we've written it there. It's a 0. That's fine. 0 point. Yeah, that's good. That's good. That is good. Yeah, that's perfect. Yeah, and you could have done it that way. I think personally this way is easier though. But yeah, let me know which way you guys did it in the comments. And yeah, that's it. That's question 4 finished. Okie dokie. Question 5. It says duck eggs are classed as large or small. Kyoshi knows that 35% of the eggs laid by his ducks are classed as large and the rest are classed as small. The eggs are randomly allocated to boxes, each containing 6 eggs. A box is selected at random. Calculate the probability that this box contains, for part A, exactly 2 large eggs. So what do we have here? We've got large or small eggs. There's a fixed probability of eggs being large, 35%, and we've got a sample size of 6 eggs in a box, right? So n equals 6, p equals 0.35. This is a binomial distribution if it wasn't clear. So part A, X, I'm gonna write out the binomial distribution. It's gonna be N is 6, P is 0.35. And for part I need to calculate that X is just equal to 2, isn't it? Exactly 2 large eggs. So yeah, plug it in. This is just calculator work, isn't it? So going back there, it's gonna be 7. And then I need to go to binomial PD, which is for variable 2. X is 2, N is 6, P is 0.35. And that is equal to 0.328, so 3 significant figures. So that's part I. Part double I, it says calculate the probability that this box contains more large eggs than small eggs. Well, there's 6 eggs. If they were the same amount, there would be 3, 3. So if there's more large, then it has to be more than 3, which is 4 at the minimum. So what we're actually calculating here is, it's just a fancy way of asking you to calculate x being greater than or equal to 4, isn't it? Like they just worded it in a certain way. But yeah, that's all they're asking you for. So we're going to do this now. This is 1 minus the probability of x being less than or equal to 3, isn't it? So what I'm going to do is I'm going to find out x being less than or equal to 3 on my calculator and then just take that from 1. So 7, I need to now go to binomial CD, don't I, which is going to be there. 2 is going to be variable. And then I need to change that 2 to a 3. So that's going to be like that there. And I get that. So it's going to be 1 minus 0.8825, blah, blah, blah. So putting that into the calculator, I'm going to go back to calculations. If I click answer, that number's stored. 1 minus answer is 0.117 to 3 significant figures. Yeah. And that's it. That's part A. Finished. Okay, so part B says Kyoshi believes that the proportion of large eggs produced by the ducks will increase if he adds a supplement to the duck's food. To check his belief, he takes a random sample of 50 eggs after the supplement has been added to the duck's food and finds that 25 of them are large eggs. Part B says use a suitable test at the 5% level of significance to determine whether or not there is evidence to support Kaishi's belief. State your hypotheses clearly, and this is 5 marks. Okay, so it's hypothesis test with a binomial distribution. What you always want to do is firstly set out your distribution. So in this case, it's going to be binomially distributed, and we've got a sample of 50, isn't it? Right? And remember, with a hypothesis test, we assume the null hypothesis, right? So the probability is going to stay 35%, right? And obviously, we've got this here, H naught, H1. So this is a one-tailed test, isn't it? Because Kyoshi believes that the proportion of eggs of the ducks will increase, right? So it's going one way, so it's one-tailed. So the null hypothesis is going to be 0.35 for P, and the alternative is going to be P is greater than 0.35, isn't it? And essentially, with a hypothesis test, you're finding the probability of observing a certain value if you assume that the null hypothesis is true, right? Or given the null hypothesis is true. So that word observed that I used, there's always an observed value here, right? So let's read the sentence. To check his belief, he takes a random sample of 50 eggs after the supplement has been added to the duck's food and finds 25 of them are large eggs. So this is going to be your observed value. And I always write this every single time. You'll never get it wrong. So the observed value is going to be 25. And you want to find out the probability of getting this value, assuming the probability is 0.35, the null hypothesis, right? And then whatever you get here, your t-stat, you compare to your significance level, right? And if it's less than, then you reject it. If it's greater than, then you accept your H0, your null hypothesis. So I'll say that again. If it's less than, you reject the null hypothesis. If it's greater than, then you accept the null hypothesis, right? So we need to work out what this is. So I'm going to put this into my calculator and see what I get. So going to be 7. I'm going to go to binomial CD, right? To be fair, my calculator doesn't do it that way. So let me write this out first. That's going to be 1 minus the probability of x being less than or equal to 24, isn't it? So I'm going to calculate 24, take it from 1. So binomial CD, and then I'm going to do 2 variable. 24 is there. I've already got it in. 24 is x, n is 50, and p is 0.35. That's already in. So if I click equals, I get that number there. So it's going to be 1 minus and then 0.97 933, blah blah blah. So what is that equal to? So we're going to just go back to the calculation now. That is stored. That's fine. That's brilliant. We didn't have. It's going to be 1 minus answer, which is going to be 0.02, right? 0.6, blah, blah, blah. Now, the significance level was 5%, which is over there. That's 0.05. This number is smaller than 0.05. So what do? You reject H0. So that's what I always write. You're going to reject H0 and you're going to accept H1. And then just like in question 1 with the hypothesis there, you want to contextualize it now when you get to this point. So what you're going to say is this is statistically significant. And you're just going to say a general statement in the context of the question. There is evidence. There is evidence at the 5% level of significance. There is evidence at the 5% level of significance. You know what? That's a bit wordy. You know what? All you need to write this. There is evidence at the 5% level, or there is evidence. All you need to do is this. There is evidence to support Kayoshi's belief, right? Kayoshi's belief. This reminds me of Avatar, The Legend of Aang, and that was a girl, wasn't it? So maybe Kayoshi's a unisex name. But yeah. Support Kayoshi's belief, which was that adding a supplement would increase the proportion of large eggs, wasn't it? Kayoshi believes that the proportion of large eggs produced by the ducks will increase if he has the supplement. Yeah. So you're gonna say this is statistically significant. There is evidence to support Kayoshi's belief that adding a supplement or the supplement, whatever this supplement is, will increase. So the handwriting is bad. The proportion of large eggs. So again, just write a statement in the context of the question to get the final marks. Let me just read that. Statistically significant, there is evidence to support Kayoshi's belief that adding the supplement will increase the proportion of large eggs. Yeah, perfect. Brilliant. That's it. That's part B. Okay, so part C says Kayoshi sells boxes that contain more large eggs than small eggs for a profit of £1.20, and the rest of the boxes for a profit of 60p. The proportion of large eggs produced by Koshi's ducks has increased to 45%, and the cost of the supplement is 10p per box of eggs. Given that the eggs are still randomly allocated to boxes, Part C says explain whether or not Kayoshi should continue to add the supplement to the duck's food in order to make a great profit. And this is a 5 marker. Okay, so there's a lot going on here, but all you want to do is just think about this methodically, right? We've got two instances here. We've got the duck, right? It lays large eggs at a proportion of 35%. And after this supplement's been added, it's increased to 45%. We want to work out the profit that Kayoshi was making before this supplement was added and after. If the profit after the supplement is added is greater than it before, then then Kayoshi should continue. If it's not, then he should stop. So what we want to do is calculate the profit before and after this supplement has been added. So what I'm going to do is I'm going to write PBS, and this is going to stand for profit before supplement. Supplement. Okay. How do we actually calculate that though? Well, remember, look at the first sentence here. It says that they're selling boxes that contain more large eggs than small eggs for a profit of £1.20, and the rest of the boxes for a profit of 60p. Now, these boxes, again, they are still randomly, these X's are, these x's. These eggs are still randomly allocated to boxes, right? So we don't know which boxes contain more large and more small and so on and so forth. So obviously we're going to find out the proportion, the probability, which is what we did in part A. So remember, for part A, x was binomially distributed and there were 6 boxes. The duck was laying eggs at 35%, right? Large eggs, by the way. And what was a good box, right? That was when it was x is greater than or equal to 4, when there were more large eggs than small eggs, right? So what was this equal to? This was equal to 0.117. And to be fair, that actual calculation, right? I'm gonna do another decimal place. It was that to 4 decimal places. So I'm gonna use that just because it's more accurate, right? And I think this should be fine in an exam. So what I'm gonna call this a good box, right? This is a probability of me getting a good box. The profit before the supplement, right, is gonna be equal to, well, the proportion of me getting a good box, right? The probability of me getting a good box, which is gonna be, I'll write like this first. Probability of good, right? Multiplied by how much I'm selling it for, which is £1.20, right? Plus, and then the probability of me getting a not good box, which would be boxes that contain more large eggs than small, isn't it, right? So I'll write not good here, like that. And I will times this by the amount I'm selling it for, which would be 60p in this case. Now there's no additional cost here, so it's just going to be equal to this. So now from here, what I'm going to do is just literally put this in. So it's going to be 0.1174 times by £1.20 plus, and then it's going to be 1 minus that, isn't it, right? 1 minus 0.1174 times by 60, like that. And what I'm calculating here is the profit per box, isn't it, right? So I'm going to put this into the calculator and see what I get. So I'm going to just do 0.1174. I'm going to store it, right? So I don't need to write again. And then it's just going to be that number. So answer times £1.20 plus, and then I'm going to do a bracket and I'm going to do 1 minus answer, won't I? So 1 minus answer times by 60p, like that. And hold on, I think I've written something wrong. 0.6, 1 point. Oh, I wrote plus, didn't I? That should be a multiply. That should be a multiply. Okay, I need to do it again because it's stored. So what I'll do actually, yeah, to be fair, I'll just do it again. So I'll just do, no, I won't do it again. I'll just write it like this. 1174 times by 120, and then plus, and then 1 minus 0.1174, like that. And then times 60p. Let me just double check that looks good. Yep, that's fine. Times in plus 1 minus, that's fine. Perfect. And I get that there. So this here is going to be the expected profit per box, isn't it? Right? And this is before the supplement is added. What I want to do now is calculate the profit after the supplement has been added and compare it to this number here. Right? So what I'm going to do now is I'm going to write PAS. PAS. And this is going to be profit after supplement. All right? Profit after supplement. Okay. So now remember the supplement has been added and the proportion of large eggs has increased to 45%, isn't it? So what you want to do now is you want to remember it's still 6 boxes. You want to calculate the probability of you getting a good box, right? With this supplement that the duck is now taking. So it's the same probability. Remember, more large eggs than small is going to be x is greater than or equal to 4 because there's still 6 eggs here. So I want to calculate this and see what I get, and then just do the exact same thing here. So that's going to be this one. So what I'll do is I'll do this one. I'll do it to 4DP as well. So I'll go to 7. I'm going to go to binomial CD, which is 1. I'm going to go to 2, which is variable, and I'm going to put in 3. Fine. 6, and then instead of putting 35%, I'm going to put 45%, aren't I? Which is that number there, 0.45, like that. Let me just check. That's fine. That's fine. That's fine. And I get that there, right? So it's going to be 1 minus that number, 7447, sorry, 447, like that. And then that is equal to, and I'll give it to 4DP. So answer that's stored, 1 minus answer is equal to that number there, which is 0.2553, isn't it? 0.2553. So this is the probability of you getting any random box and it contains more large eggs than small eggs, right? So what would the profit be after the supplement? Again, it's the same structure. However, you're going to, let me put this here. So in this case, there is a cost, the cost of the supplement, right? So, whoops. That doesn't look good. Let me just tidy it up a bit. So I'm going to just write equals and then that should be a G like that. And then that should be, yeah, that's fine. And then remember this one, there's a cost. The cost per box for the supplement is 10 pence. So the profit, I have to minus 10p per box, don't I? So it's going to be equal to this. Now, what is this equal to? It's going to be a good box, which is going to be 0.2553 in this case, times by 120, plus a not good box, which is just going to be 1 minus that, times by 60 minus the 10p like that. And I'm going to put this in my calculator to see what we get. So I'm just going to put it in. I'm going to do it to 4dp. So 0.225, so 2553 like that. And then I'm going to times this by 120 plus, and then it's going to be 1 minus that same number for a not good box. 2553. And I'm going to times this by 60. And then I'm going to take away 10p. Let me just double check I've written that correctly. I think it's all good though. So yeah, that's fine. Times by 120 plus 1 minus same number. That's fine. Yep. Click equals. I get that number there. Yeah. Which is going to be 0.65318. Okay. So this is the profit after the supplement per box. The profit before was that. So it's about 67p, right? This one is about 65p, right? So he's at a loss, isn't he? Right? He's earning less per box, right, with this increased supplement. So should Kaiushi continue? He shouldn't, right? So what you're gonna say now is just compare these two. So I put in a box here, right? Comparing that one. Whoops. Comparing that one with this one right here. You're gonna say, just to conclude, you're going to say that this number 0.65318 is less than that number 0.67. What was it? Double four? Yeah. Right? So Kyoshi should not continue with the supplement, right? So although the supplement is increasing the proportion of large eggs that his duck is laying, right? It's coming at a cost. It's not worth the cost, right? Because overall he's earning less money than he was before, so he should not continue. And yeah, that's it. Finished. Okay, so question 6 says Shea is practicing his basketball free throws. As he continues to shoot, his arms begin to tire, and the probability of making a successful shot decreases with each additional attempt. The random variable y represents the number of shots he attempts, and the probability distribution of y is given by probability of y equals n plus 1 is 3 quarters, the probability of y equaling n for n equals 1, 2, 3, and so on and so forth. Part A says, given that the probability of y equaling 1 is k, show that the probability of y equaling 3 is 9 over 16k, and this is only one mark. So what I've done here is I've actually just got everything that I need summarized down here for A. Now, as you can see, this is a recursive relationship, isn't it, right? So what I would do is essentially just plug in everything that I know. Let me just move this here. So we know that the probability of y equaling 1 is k. If I use this relationship here, remember, this is n plus 1, this is n. On the left is 1 more than 1 on the right. So I can say that the probability of y equaling 2, right? From that relationship, it's going to be 3 quarters, the probability of y equaling 1, isn't it? Right? And I know that that's k. So therefore, the probability of y equaling 2 is going to be 3 quarters k. And then now remember, we want to show that that's probability of y equals 3 is 9 over 16. So we're going to do probability of y equaling 3 is equal to 3 quarters and the probability of y equaling 2. Right? And obviously now we know what that is. That is 3 quarters k. So it's going to be 3 quarters times by 3 quarters k, which is 9 over 16k. So therefore, we have shown it. Fantastic. So that is part A. Now, what does part B say? It says, hence, show that the probability of y equaling n is k 3/4 to the n minus 1. And this is a 2 marker. So, hence, right, what's going on here? From term to term, we are timesing by a fixed number, which is 3/4. This is a geometric series, isn't it? Right. So remember, even though pure is done, right, it's never really done because it can come up in your applied paper. It came up famously in 2023 with the integration by parts. So yeah, it can come up as well. So and another time, I think 2018 it came up as well. But anyways, we want to show that. Now, remember, what do we have so far? What we can do is we can tabulate everything that we have here. I think that's always good to do. So, I'm gonna say this is probability, this is gonna equal y, like that. It's gonna be the probability of y equaling n, like that, isn't it? So, no, that should be an n, to be fair. That would be an n, and then it'll be like this, and it's from 1, 2, 3, 4, 5, and so on and so forth, right? Now, if I want y equal n, a general term, let me just write everything with it. This was k, this was 3/4 k, and this was 9/16k, and so on and so forth, right? If I want just y equal n, so at any specific point, it's just the nth term formula for a geometric series, right? So remember, the general formula is un is equal to a times r to the n minus 1. So probability of y equaling n, right, is going to be the same. Now, what is a? Now, if I look at this here, our first term is k, right? Our common ratio, we look at the table. How are we going from one term to another? We're just timesing by that 3/4, isn't it? So therefore, I'm going to say r is equal to 3/4, right? So therefore, I can say the probability of y equaling n, right, is going to equal a, which is k, and then r, which is 3/4. And then we can see here it's the same thing, n minus 1, nth term. And that is it. And that will give you the full marks in part B. So that's 2 marks. I said full marks like it's like 20 marks or something. But anyways, cool. So that's part B. Now, part C says, show that K is a quarter, right? So let me grab that. This is a 3 marker now. So show that K is a quarter. Let's do that. So what I'm going to do is I'm going to grab that table again, actually, because it's gonna be helpful. So let me grab that. And yeah, we're tabulating it, right? A discrete random variable, right? We know that all these probabilities, right, they must sum to 1. We've identified this is a geometric series, so we can just use the sum to infinity, isn't it? So let me just get a couple of more terms. So the next term here would be 3 times 3 is, sorry, 9 times 3 is going to be 27. And then 16 times 4 is going to be 64, like that. And so on and so forth. Let me get my calculator. And then the next one is going to be that, isn't it? 3/4 times by 27. Actually, no, it's not actually. Times by 27 over, actually, it might be. We'll find out. 81 over 256. So the next one's going to be like that, right? Okay. And so on and so forth, right? Now, we know that this is a geometric series, right? And we know that the sum of each of these probabilities, right? Just from normal probability tables, these have to add up to 1. So what I'm going to do is I'm going to say then that k plus 3/4 k plus 9/16k plus 27/64k and so on and so forth, this must equal 1. Now, this right here we know is geometric. This is a geometric series, like that. So what you can do is identify your first term, identify your common ratio, and use the sum to infinity formula. Let me write the sum to infinity formula, which is a over 1 minus r. Now, in our case, a is going to equal k, right? The common ratio is 3/4, right? So therefore, what we can say is that this thing in the bracket, or this thing here, right? The left-hand side is going to equal, I'll do it here. It's literally just going to equal, it's going to be k over 1 minus 3/4, like that. And this is equal to 1, like that. So therefore, I've got k over 1 minus 3/4 is going to be, we're going to be left with 1/4, like that. When we divide by a quarter, we're timesing by 4. So 4k is equal to 1. So therefore, k is equal to 1/4. Perfect. So yeah, that's it. Another thing you could have done as well is you could have taken out the k like this, and then just do 1 plus 3/4 and then 9/16, and so on and so forth, right? And then find the sum to infinity of that. I normally do it this way, but I think I mean, I know you don't need to, but I don't know why. I just like to, I don't know. But yeah, you could do it that way, just in case anybody did it that way as well. So you'd get the sum to infinity inside the bracket would just be 4, wouldn't it? And then you divide by the 4 to get a quarter. So you could have done it that way, but yeah, perfect. So that's done. K is a quarter. Now, what does the next part say? It says, we have to go up. It says find the probability that y being between 3 and 6 inclusive on both sides. So, and that is 2 marks. So now that we know k is a quarter, um, this is not too bad. So let me grab that, and I'm gonna get this table. This table is just the key to everything, isn't it? So, putting that there. What would that be? So I'm going to put a 6 there, right? Because I want 3 to 6, don't I? So I need to get the values for 3, 4, 5, and 6, and then figure out what they are. So what would that one be? 81/256. I'm going to times that by 3/4. Times that by 3/4 is going to equal 243/1024. 243/1024 k, right? Now that means that the probability of y being between those two, 3 and 6, right? This is just going to equal these four, right? So it's going to equal 1, 2, 3, 4. I'm going to add all of those together, right? So it's going to be 9/16 k plus 27/64 k plus 81/256 k plus 243/1024 k, right? I need to work out what that is. Now we know what k is. K is a quarter, isn't it? Right? So we can put it in. What I'll do first though is I'll take out or to be fair, I just realized, could you not just use sum to n terms for 4 then? Obviously start from 9/16 k, but I think that's a bit extra. Anyways, let me just take out the k. 9/16 plus 27/64 plus 81/256 plus 243/1024, like that. And obviously k I'll still write there, and then let me just put that into the calculator and see what I get. So it's going to be 9/16 plus 27/64 plus 81/256. Whoa. 81/256, and then plus, we just double check. That's fine. That's fine. That's fine. And then 243/1024, and that gives us that number there. So 1575/1024. Now k we know is a quarter, isn't it? So it's going to be 1/4 times 1575/1024, which is equal to, I'm going to just do answer times a quarter, and I get that number there, right? Which is 1575/4096. Perfect. So that's done. Let me just double check that's all correct though. 9/16. Let me just check. Yeah, that's fine. That looks good to me. Yeah, that looks good to me. Yeah, that's perfect. Okay, perfect. So that's done. And then part E, I think it was E or D. What are we on? I think we're on E. Yeah. So part E says explain why this model may not be suitable to describe the probability of Shay making a shot in the long term. So remember, Shay's practices free throws. His arms begin to tight as he keeps shooting. What is happening each time? What is the probability of of him getting a shot each time? It's decreasing at a fixed rate. That is the problem here, right? In reality, he could get tired, and maybe when he's doing the free throws, right? The difference between one and the one after it is much greater than it being 3/4 or 75%, right? So that is the problem. The fact that the probability is decreasing by a fixed rate. In reality, that wouldn't happen, right? So what you're gonna just say for part E, just to write, because that's I'll type it because just easier, right? So you could just say here, whoops, you could just say the model assumes that the probability decreases at a fixed rate, right? I'll put in brackets 3/4, right? In reality, Shay may tire and just something contextual that makes sense. So in reality, Shay may tire and the rate may drop even further, right? Or it could even increase potentially, right? No, actually, no, it won't increase because we're modeling the fact that the probabilities are going down. So yeah, just something like that. The model assumes that probability decreases at a fixed rate, and relative shade may tie, and the rate may drop even further. So the main thing is, and we're at the main thing is that it won't be fixed. Yeah, that's it, and that is question 6 finished. Okay, so question 7 says the random variable R has a normal distribution with mean 12 and standard deviation 4. Part A says find the probability that R is between 0 and 20 for 1 mark. So this is just calculator work. So put this into a calculator is going to be gonna go to menu 7 distribution, normal CD, and then lower bound is 0, that's fine. Upper bound is 20. Standard deviation is 4. The mean is 12. So that is equal to that number there, which is 0.976 to three significant figures. 0.97, let me just check again. 976, yeah, perfect. But I will put some extra ones as well, just in case I need to use it like that, right? So we've got that there. Okay, perfect. So now, part B, it says Eleanor, a gardener, is planning to create a circular flower bed in her garden. The radius of the flower bed, R, is normally distributed with a mean of 12 centimeters and a standard deviation of 4 centimeters. Eleanor aims for the area of the flower bed to exceed 150 centimeters squared. However, due to space constraints in her garden, the radius cannot exceed 20 centimeters. Part B says find the probability that the area of the flower bed exceeds 150 centimeters squared given the restriction on the radius. And this is a 5 marker. Now, it does seem like a lot, right? But remember, at the end of the day, you're finding the probability, right? You have a random variable R, which is normally distributed, right? So we're looking for some probability in regards to R. Now we've got a couple of constraints, right? The first constraint number 1, is that the radius cannot exceed 20 centimeters, right? Now remember, I'm going to put less than 20, but remember a radius is a length, right? It cannot be less than 0. So what that also means is that it has to be between 0 and 20. So I'm going to put that there. And then as well as that, the area, which I'm going to call A, right? We want the area to exceed 150, isn't it, right? So I'm going to say area is going to be greater than 150, right? Okay. Now, we're looking for a probability. Remember, probability is in terms of R. We're dealing with the random variable R. So how do we go about that? Well, remember, we're dealing with a flower bed. It's circular, as they told us. So we could model the area to just be a circle, right? And that's going to be pi r squared. So what I'm going to do is I'm going to replace A and put it in terms of R because the area is just pi, and I'll do the radius squared like that. And this has to be greater than 150. And what we're doing here is we're going to find the radius, the corresponding radius for an area which would exceed 150, right? So this is just a matter of solving it now. So I'm going to do R squared is greater than 150 over pi. And that would mean that R would have to be greater than the square root of 150 over pi. This is my critical value here. So let's just see what that is in context, right? We'll use that, but let's just see where it is in context. So 150 divided by pi. This is equal to 6.909, blah, blah, blah. So essentially, we want the radius to be approximately more than 6.9 centimeters, right? So I'll do that. Okay. Now let's read the question again. Find the probability that the area of the flower bed exceeds 150 centimeters squared given the restriction on the radius. Given, right? Given the restriction. This is a conditional probability. So what you want to be thinking of is your conditional probability formula, right? So what we're actually doing here is we're finding the probability, right, that R, right, is greater than 6.909 given that the radius does not exceed 20, right? Which is R being between 0 and 20. Right. This is what we're calculating. This is a conditional probability. Again, let's read it. We'll find the probability that the radius exceeds 6.909 because that corresponds to the area exceed 150 centimeters squared, given that the radius doesn't exceed 20, which means it's between 0 and 20. So Conditional probability. How do we do this? Remember your conditional probability formula. Probability of A, given that B happens, is equal to the probability of A intersection B over the probability that B happens, right? So we just need to apply that exact same thing here. So let me put this here and let's see what that actually means then. So if I copy that and put it here, and then let's literally write that. So this is going to be equal to the probability of the intersection of these two. So R being greater than 6.909, and then the intersection of R being in between 0 and 20. Hold on, that looks very, very missing it again. Just so it's neat. So 0, R, and 20, right? And then over probability of R being between 0 and 20. And this is good news because we've actually done part of this in part A, right? We've worked out this calculation already. So now it's the top one. Now, this type of question where you've got a conditional probability within a normal distribution is a very nice type of question. And I think it came up, I believe it was 2018 with the calculators. I think it was about a test and you had to replace the batteries in the calculator. I can't remember exactly, but I think that's the paper, which is where I got the inspiration from this question. So with this one, how do we work out this one? What you want to do, guys, remember your normal distribution, right, has a curve. Visualize it. What is the actual probability that they're asking you for here? So if I draw the normal distribution curve, right, we know that the mean was 12. Whoops. The mean was 12 there, like that. Standard deviation is 4. So we want the probability that R is greater than 6.909. So that's going to be over here. So let's just say it's over there. And we want it to be between 0 and 20, right? So 0 and 20 is going to be over there, isn't it? So let's just say, for example, 0 is on the left side there, and let's say 20 is there, like that. We've got these two areas. What is the probability of R being greater than 6.909 and also at the same time being between 0 and 20? It's just literally just going to be this thing, isn't it? It's going to be this area right here that we're looking for. So that will go on the numerator. So what I'm going to do now is calculate that and put that on the numerator. So what I'm going to do, let me just write here so it's super clear. This is just equal to the probability of R being in between 6.909 and 20. Hold on. It's so hard to write with these. We do it again. 6.909, blah, 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 and 20. That's what we're calculating for that one. Over the probability of R being between those two. So that's literally what we're calculating. So therefore, let's do that and see what we get. So calculator. Okay, I've got that number. So what I'm going to do is I'm going to go to normal 7 and then 2CD, and I'm going to put the lower bound to be that number there, which is that one. Going to be 20 there. That one, the standard deviation was 4. The mean was 12. So I get that on the numerator. So I'm going to put this there. That's going to be 0.875, and I'll put it to 6565 0.875 that should be fine, right? Over, and then the probability of it being between 0 and 20, which is what we did before, which is over there. But just to be super safe, I'm going to just write out again, just so I get a couple of decimal places. I'm going to go there and I'm going to go put 0 in again, and then I'm going to put this there and I'm going to put this in. So 0.9758, you can see 0.9758, so just 9, isn't it? Right? Yeah, just 9 essentially. Let me just double check. 0.9758, 0.975 9 actually. Yeah. Well, you know what I'll do? I'll just use that answer, to be fair. Yeah. So I've got that stored. So what I'm going to do now is I'm going to go to my calculation now. That number is stored on the bottom. I've got that on the numerator. So I'm going to just do literally this. 0.875 657 over answer. And I get that number there. So the answer is going to be 0.897, blah, blah, blah. To 3 significant figures, it's just going to literally be 0.9897. Yeah. to 3SF. So let me write 0.987 to 3SF. And that is it. That is the answer to part B. So again, this type of question, I haven't seen it come up in a while, but it can do. So I thought it would be good to do. And yeah, that's it. That's part B finished. Okay, so part C says Eleanor has recently purchased a new fertilizer from a manufacturer who claims the new fertilizer is the real deal. It increases the flower bed's radius every time. Based on historical data, the radius of the flower bed using the gardener's current fertilizer is normally distributed with a mean of 12 centimeters and a standard deviation of 4. The gardener decides to test the new fertilizer by planting 10 flower beds. The mean radius observed from this sample is 13.5 centimeters. Part C says, stating your hypotheses clearly and using a 5% significance level, test whether or not there is sufficient evidence to support the manufacturer's claim that the new fertilizer increases the flower bed's radius. And this is a 5 marker. So again, guys, just standard hypothesis system with normal distribution. It's very, very similar to binomial, whereby you have a significance level, in this case 5%, and you're finding the probability of observing a certain value under this assumed null hypothesis, right? And obviously you just compare it to significance level. So what do we do here? Well, firstly, we know that historically, the radius is normally distributed with a mean of 12 and the standard deviation of 4, so 4 squared there. Now, we're dealing with a sample, aren't we? So remember, we have to do R hat here. And now this is going to be normally distributed with the same mean. But remember, you always divide the variance by the sample size, which in this case is going to be 10 flower beds, like that. Now, again, you're always looking for a null and an alternative hypothesis. So what is that going to be? Well, let's look at the statement again. New fertilizer is the real deal. It increases the flower bed's radius. So we know that the null hypothesis is going to be what we assume to be true, which is the mean of being 12. And the alternative is going to be mu is greater than 12, isn't it? So it's a one-tail test. Now, once we're here, what do we need to do? Well, we need to look for the observed value. The mean radius observed from this sample is 13.5. So the observed value, I always write this, by the way, observed is equal to 13.5. And what you're doing is you're finding the probability of observing this value, assuming that the null hypothesis is true. So what I need to do is I need to find the probability of R being greater than 13.5. And then I will compare this with the significance level. So getting my calculator, I'm going to put everything in. So normal CD is where we're at. We're looking for 13.5, that's the lower bound. 10 to 10 is going to be the upper bound, like that. The standard deviation, right, is going to be the square root of the variance. So remember, the variance in this case is going to be 4 squared over 10. The standard deviation, right, is going to be the square root of that, which is going to be 4 over root 10, right? So that's what I'm going to put into the calculator. So it's going to be 4 divided by root 10, and then the mean is 12. So this is the answer that I get. So the probability of observing that 13.5 is going to be 0.1178 approximately. And then, yeah, we compare this with the significance level, which we know was 5%, right? Now, I'm going to write 0.1178 and then 0.05. This number is greater than 0.05. So if your value here, your T statistic, right, is greater than your significance level, then you fail to reject H0. Yes, you fail to reject H0. So we're going to accept H0. So I'm going to say you're going to accept H0 and you're going to reject the alternative H1, right? And now once you're here, guys, to get the final mark, you need to contextualize it, right? So what you're going to say, there is insufficient evidence to support the manufacturer's claim. The manufacturer's claim. And obviously, to be fair, I think this will be fine, but to really bring on, let me just write claim again. Do you know what I'm going to start doing? I'm going to start typing these because it's very hard to write with this graphic tablet, and you guys probably think my handwriting is awful. So there is insufficient evidence to support the manufacturer's claim that the new fertilizer, I'm going to write fertilizer increases the flower bed's radius. And that is it. That will give you the full 5 marks. And yeah, that is question 7 finished. Okay, so question 8 says a man throws a ball into the air so that at the instant when the ball leaves his hand, the ball is 2 meters above the ground and is moving vertically upwards with a speed of 9 meters per second. The motion of the ball is modeled as that of a particle moving freely under gravity, and the acceleration due to gravity is modeled as being of constant magnitude 10 meters per second per second. The ball hits the ground t seconds after leaving the man's hand. Using the model, find the value of t for 4 marks. Okay, so I like to visualize these questions. So what do we have? We've got, let's say we've got a surface here. We've got a man like that. Let's say this man here is 2 meters tall. So we're going to have like that there. And he projects, sorry, that doesn't look good, does it? Okay, doesn't really matter. So let's just say he's like that, for example. He's projecting a particle, right? This guy's 2 meters tall guy, taller than me, that's for sure. 2 meters. What do we know? Vertically upwards, with an initial speed of 9, isn't it? So u equals 9, right? What else do we know? We know that the acceleration due to gravity in this case is 10, right? So normally it's 9.8, but they've told you it's 10, so you're going to use 10 instead. And let's model upwards as positive. So what we're going to have here is that we're going to have the acceleration is going to be -10. It's going to act the opposite way. U is equal to 9. What else do we know? We're looking for the value of t. The ball hits the ground. So we're modeling it when it hits the ground. So it's going to go there, right? And if we're modeling upwards as positive, that means that the displacement is going to be -2, isn't it? So S is going to equal -2. And we're looking for the time, capital T, for when it happens. So we are here now. Suvat, what formula connects these letters together? A, U, S, and T. It's just a formula. S is equal to UT plus a half AT squared. So plugging in everything is going to be -2 is going to equal U, which is 9. And then T is capital T plus a half. And then A is -10. And then T squared. And then just tidying that up a bit. So what do we have here? We're going to have, do it here. It's going to be -2 is equal to 9T. That's going to be -5T squared. It's a quadratic, move everything from right to left. So it's going to be 5T squared minus 9T. -2 is equal to 0, isn't it? So we need to solve for t. What can we do? We can factorize that. 5 times -2 is -10. What two factors of -10 are going to make -9? It's going to be a -10 and a +1, isn't it? So that means we can put two brackets at this equals 0. We can put a 5t there and a 5t there. Put the two numbers in, -10 plus 1. So we get that there. Take out the 5, so it's going to be 5 bracket t minus 2, and then 5t plus 1 equals 0. So this is actually the factorization now. Cross that out. So therefore, it's going to be t equals 2 from there, or 5t plus 1 is going to equal 0, isn't it? So 5t is going to equal -1, so t is going to equal -1 over 5. However, we're dealing with time though, aren't we? So we can't have a negative time, so therefore we're going to reject this one. Yeah, so therefore t is equal to 2. And that's it. And that is our question 8 finished. We just zoom out. Yeah, perfect. Okay, so question 9 says a car of mass 1,200 kg is towing a trailer of mass 600 kg up a straight road, as shown in figure 4. The road is inclined at an angle alpha to the horizontal, where sine alpha is 1/12. The driving force produced by the engine of the car is 3,000 newtons. The car moves with acceleration 0.75 meters per second. The non-gravitational resistance to motion of the car is modeled as a constant force of magnitude 2r newtons, and the trailer is modeled as a constant force of magnitude r newtons. The car and the trailer are modeled as particles. The tow bar between the car and trailer is modeled as a light rod that is parallel to the direction of motion. Using the model, part A says me to show the value of r is 60, right, for 4 marks. So firstly, I've got the diagram here, right? Just so we can annotate it, and I've got the questions, and I've got the question next to it. So firstly, you want to get your force diagram going. That's the first thing. Now, car of mass 1,200 kg. That means that this is going to be 1,200 g, isn't it? 1,200 g. This is 600 g. What else do we have? These are going to have reaction forces, but we're not going to need that for now. I'll just put this up there, right? That I'll just write them up so we know that they're there anyway. What else? the driving force is produced by an engine of the car is the driving force produced by the engine of the car is 3,000 newtons. So I'm gonna have a driving force of 3,000 newtons going that way, like that. And then what else do we know? The car moves with acceleration 0.75. So I'm gonna say A is equal to 0.75, and I'm gonna do like an arrow there. So it's going like that. And the car is modeled as the non-gravitational resistance to motion of the car is 2R, right? So I'm gonna put a 2R over there. So that's gonna be 2R. Like that, and then this one's going to be R, isn't it? Like that. And then let's not forget the tension in the tow bar. Yeah. So I'm going to put a T there and a T like that. And I think that is it. So obviously we can resolve these as well, actually, can't we? So we can resolve these like that. Remember, this angle is always the same as alpha. So that's going to be alpha 2. Hold on, let me just do it a bit neater. So it looks neat. So we got that there. And then it's going to be like that. And it's going to be like that, and then this is alpha, like that. So essentially, if this was 600G, this one here is going to be 600G. That's opposite the angle G sine alpha. That's going to be 600G cos alpha, isn't it? Like that. And then this is going to be 1200 G cos alpha. That's going to be 1200 G sine alpha, like that. And to be honest, that means I don't need this, do I? Okay, and yeah, that is it now. The question asks us to show that the value of R is 60. Now, with these types of questions, they don't really come up a lot. I don't think I've ever seen a connected particles questions like this in one of the exams, but you never know, it could happen this year. But yes, in a year 12 topic, you want to treat it as a whole system, right? So what I'm going to do is, remember, we know it's going that way. I'm going to do F equals MA, and I'm going to treat it as a whole system. So what I'm going to do, actually, because I've got this diagram, let me copy this and put this diagram over here. Like that. Okay. I'm just kind of scared that my face is covering it. So, all right, we need to find R, don't we? So we're finding R. So again, we're going to use F equals MA, but for the whole system. Yeah. So F equals MA for, whoops, for whole system, right? That would be, well, what's going on here is a lot, to be fair. It's going that way. I'm going to highlight all of the forces going in one direction. So I've got the 3,000 force, right? So that's going to be the driving force. I'll do it here. And then what is happening? Well, we've got these two forces, which are the parallel components of the weights, right? So that one and that one, isn't it? Yeah. So that's going to be minus 1,200 G sine alpha minus 600 G sine alpha, like that. And then as well as that, we've also got the resistive forces as well. So we've got this 2R and we've got this R there, like that. So minus 2R and R, right? And obviously the tensions will cancel, won't they? So yeah, this is it, I believe. Yeah, that's it. And this is going to equal the mass of the object, which in this case, remember, we're doing it for the whole system. It's 1,200 kilograms plus 600 is going to be 1,800 times the acceleration, so which is 0.75. So I've got this here. Now let's tidy this up here. So this is going to be 3,000 minus, that's going to be 1,800 G sine alpha, isn't it? Like that. And then that's going to be minus 3R. And then this is equal to whatever that is. So now we can plug in everything and see what we get. So I remember sine alpha was 5 over 12, if I'm not mistaken. 1 over 12. Apologies. So sine alpha is 1 over 12. So it's going to be 3,000 minus 1,800 G times by 1 over 12. Like that. And then obviously we could just calculate what that is. So I'll do that in my calculator, to be fair. So that's going to be, the right hand side is going to be 1,800 times by 0.75, that's going to be 1350. So 1350 would go, whoops, minus 3R, and that will equal 1350, like that. And then that means I can just move that there, and then move that there, and then divide by 3. So therefore, it's going to be 3R on the right, and then it's going to be what these are. So let me work that out. So it's going to be, just so it's super neat, right? So was that 3,000, right? Yeah, so 3,000 minus 1,800 times by 9.8. That gives us, hold on, let me just check. Oh yeah, times the 1/12. Forgot to times by the 1/12. That's gonna be 1/12, like that. That equals 1530. Yeah, so that's gonna be 1530 over there. Minus 1350 is gonna equal that. So I'll put it in the calculator. 1530 minus 1350. It's gonna be 180. Yeah, so it's gonna be 180 is equal to 3R. Divide that by 3, that's just 60, isn't it? So therefore R is equal to 60. And that's what we wanted to show. Let's just double check. Yeah, perfect. Show that the value of R is 60. So that's good. So remember, whole system, you can do it this way. And then obviously part B says find the tension in the tow bar. That's for 3 marks. Now remember this one, if this comes up, you can always treat it in 2 parts. If you want to isolate the tension, you could either um just model the, what is this, a van? The car, right? You can either model the car's FP as, you could split it like this basically. You could model it like that. So you could model the equation of motion separately for the car or for the for the, what is it? What is this? Trailer, right? So you can either do the car separately. So you can either do the car separately, F equals ma, or you could do the trailer. Now, when I look at it, there are fewer forces to deal with there. I mean, it doesn't actually matter, to be honest. I'll do the trailer though, right? I feel like the trailer is always the easier one. So I'm gonna do the trailer. So if I grab that there, or I'll do it here and then do the equation after. So if I do F equals ma with just the trailer, right? I'm gonna write F equals ma for trailer only. Well, that will equal, it's going to equal, this is the driving force. That T is the driving force there. So it's going to be T minus, um, and then we're going to minus that resistive force R, which we know is 60, by the way, and then minus the parallel component of the weight, 600 G sine alpha, like that. And this is going to equal the mass of the object, which is 600, times the acceleration, which is 0.75, like that. And then I'll copy this, and put this there, and that will allow us to calculate what that is. So I'll do it here. So now just tidying that out. Remember, we know R is 60. So therefore, I'm going to say T minus 60 minus 600 G sine alpha, which we know is 1/12. It's going to equal 600 times 0.75. So let me just tidy up a lot of things. So 600 times 9.8 times by 1/12. That is equal to 490. So minus 490 there. That will equal 600 times 3/4, which is 450, like that. And then we've got T minus 60, like that. So that's going to be T minus 550, like that. And this is going to equal 450, like that. So T is going to equal 450 plus 550, which is 1,000. So the tension in the tow bar is 1,000 newtons. And that's it. And yeah, R is 60 newtons as well. I forgot to put the newtons there, but yeah, perfect. Perfect. So that is part A, and then that's part B. Let's go to part C now. Okay, so part C says when the car and trailer are moving at a speed of 12 meters per second, the tow bar brakes. Given that the non-gravitational resistance to motion of the trailer remains unchanged, part C says use the model to find the further distance moved by the trailer before it first comes to rest. And this is a 4 marker. Now, I've got these 2 diagrams here, and you're going to see why in a moment, right? So essentially, you want to think of this as in phases, right? So phase 1, right? We have a whole system. The car and trailer are moving together. And then in phase 2, the tow bar breaks, right? And now the trailer is going to travel a little distance further up, right, before coming to rest, right? Now we need to figure out what that distance is. So there's a couple of things going on here, right? Now, firstly, the language in this question. The first thing that I see it's actually one of the last things is to rest, right? Where do we see that phrase to rest? It's suvat, right? So as well as that, you've also got a speed, right, that you're moving at. This is going to be at the start of phase 2. So this is going to be your U. So these are all indicators that you're probably doing a suvat question, right? So firstly, what I'm going to do in phase 2, we know that this is broken here, which is why I've got a little gap in the middle. So I'm going to say this is broken right here. Now, what I want to calculate, right, is the distance, right? So again, we're looking for a distance. It says comes to rest, right? We've got an initial speed, right? So what variables are those? Well, speed is u initially, right? Because when the car and trailer are moving at a speed, the tow bar brakes. So at the start of phase two, your speed is 12. So I'm going to say u equals 12. And what else do I know? Well, I know that I'm looking for a distance, so I'm gonna put that S. I'm gonna call that S, and then when it first comes to rest, so that's gonna be V, isn't it? It's gonna equal 0. Now, what I want to do, right, is I want to calculate the acceleration, right? I want to calculate the acceleration that the what is this? The trailer is traveling at, right? That way I can plug it into a formula. So I'm gonna put A here, right? Now remember, because the particles are connected, it's no longer going to be traveling with because the particles are no longer connected. I think I actually said, I'm not sure. I'll see when I watch it back. But since the trailer and the car are no longer connected, it's not going to be traveling with an acceleration of 0.75. So you now have to calculate this, right? Now, how can you do that? Well, you're just going to use F equals ma, right, for the trailer. So if I put this here, I'm going to just say F equals ma for trailer in phase two, like that. Well, what's happening here? Well, it's going to go up a bit, but there's no driving force. And what you could actually do, one of my students actually likes to do this as well, which I think is really good. The driving force is just 0. Yeah. So if you want to use F equals ma, well, then what we can say is that it's going to just literally be 0 is the driving force, and then those two resistive forces, right, are going to stay the same. It says that they remain unchanged, didn't it? So it's going to be 0 minus 60 minus 600 sine alpha, which I can calculate at this point, to be honest, right? And then this is going to equal the mass of the object, which is 600, times the acceleration. And now, since we know it's slowing down, right? Because it's going to come to rest at some point, we expect the acceleration to be negative as well. So these are the type of things that you should be thinking of when you're doing these questions. So doing that, what's that going to be? I'll just put this into my calculator. So it's going to be minus 60, um, minus 600 times by 9.8 times by 1 over 12. That gives us minus 550. Let me just make sure I got that correct there. That's fine. Minus 550 is going to equal 600A. So therefore, A is going to equal minus 550 divided by 600. And that is equal to, put that in the calculator, so minus 550, oops, minus 550 over 600 is going to equal, oops, 11 over 12, isn't it? Yeah, 11 over 12, right? And that's good because we expect the acceleration to be negative, right? So what have we got now? We found the acceleration of the trailer, right? The question asks us to work out the distance, the further distance it travels, right? Before it first comes to rest. So we've got everything we need, don't we? So I'm going to just grab all of this here. So let me put this like this now. So we are looking for S and we have A, right? So putting this in, we now know that A is minus 11 over 12. Now, Suva, what formula connects all of these four together? U, S, V, and A. V squared is equal to U squared plus 2AS, isn't it? So plugging in everything, V is going to be 0. So 0 squared is going to equal U squared, which is 12 squared, plus 2 lots of A, which is minus 11 over 12 S, like that. So that way, what do we have? So that's going to be 0. That's going to be 144. That is going to be 2 over 12 is a 6. That's going to be minus 11 over 6 S, like that. And then I can move that there. So I'm going to have 11 over 6 S is equal to 144. That means S is going to equal what? So I put 14. 144, like that. So that means that S is going to equal 144 times by 6 divided by 11. Whatever that is. So let's put this in calculator, see what we get. 144 times by 6 divided by 11 is the same as doing that, by the way. These are the exact same thing. So that's going to give us 78.54 blah blah blah, and I'll give it to three significant figures. So it's going to be 78.5 yeah, and it's in meters, I believe. Yeah, meters per second, of course. Yeah. So the answer is just 78.5 meters. Let me write to 3SF as well. And that is it. And that is the question finished. Okay, so question 10 says a particle P rests in equilibrium on a smooth horizontal plane. A system with three forces F1, F2, and F3 newtons, where F1 is equal to 3Ci plus 4Cj, and F2 is equal to minus 14i plus 7j is applied to P. Given that P remains in equilibrium, find F3 in terms of C, I, and J. And this is a 2 marker. Okay, so if it remains in equilibrium, that means that the resultant force is 0. So essentially what we're going to do for part A is we're just going to say F1 plus F2 plus F3 must equal 0, isn't it, if it's in equilibrium? So F1 is 3Ci, like that, plus 4Cj. F2 is minus 14, so I'll put it like that, minus 14i plus 7j, and then plus F3 is going to equal 0. So all I'm going to do now is just rearrange to make F3 the subject. So doing that, what I'm going to do is I'm going to say, I'm going to move everything, or you know what I'll do actually? Let me move everything from left to right first, other than F3. So be F3 is going to equal, and then it's going to be minus 3Ci. And I'll do the next I first. So 14i, like that. So yeah, that's fine. Plus 4, sorry, not plus 4C, take away 4Cj, minus 7j, right, like that, right? And then now, obviously, we just want to make it in a nice form. So F3 is going to equal, if I take out the I, put it there, it's going to be, I'll put this first, 14 minus 3C, like that, and then plus, and then take out the J, like that. I'm gonna just have minus 7 minus 4CJ, and that is gonna give me the answer for part A. Let me write this a bit neater, 14. So 14 minus 3CI plus minus 7 minus 4C J. So that's done. Part B, it says the force F3 is removed from the system. Given that C is equal to 2, find the size of the angle between the direction of I and the direction of the resultant force acting on P. Okay, so firstly, let's get that resultant force, right? Which is going to be when F3 is removed. So the resultant force is just going to be F1 plus F2, isn't it? And we know what C is. So let me just write F1 plus F2 first. So F1 plus F2 is going to be our new resultant force because F3 has been removed. And that is going to equal just these two, isn't it? These two here. So what I'm going to do, because these are actually just F1 plus F2, I'm going to just grab that and copy it and then just simplify. So like that there. Whoops. Copy like that. Put that there. Okay. So now F1 plus F2, this is just going to equal, tidying up, that's just going to be 3Ci minus 14i, like that. And then that's going to be plus 4CJ plus 7J. And then that is just going to equal 3C minus 14I. And then plus, and it's going to be 4C plus 7J. And that's going to be F1 plus F2. And we know what C is. C, they told us was 2, isn't it? So let's plug it in so we can actually get the force. So when C is equal to 2, we're going to have if C is 2, that's just going to be 6 take away 14. I plus, and then that's going to be 8 plus 7. Like that there. That is equal to minus 8I. That's going to be 15J. Like that. So this is going to be F1 plus F2. So now we've got the resultant force. What did the question say we should do? It said, find the size of the angle between the direction of I, the horizontal vector, and the direction of the resultant force acting on P. So let's actually visualize this force then. Minus AI plus 15J. Well, what does that look like? Well, it's going 8 units to the left. Let me just make it neat actually. We're going 8 units to the left, right? And then when we get there, we're going to go 15 units up, isn't it? Like that. Hold on. Can I connect it? I can. I should be able to. That's a bit odd. Normally it just magnetically goes to the endpoint. But anyways, it doesn't matter. So it's going to be like that essentially, right? And then this is going to be the components, right? This is going to be minus AI. And then this is going to be 15J. Now the actual force itself is going to be the hypotenuse, isn't it? So it's going to be this force right here, like that. So what we want to calculate, right? This is F1 plus F2, yeah? We want to calculate what this angle is, don't we? Because it says we want to calculate the angle it makes with the direction of I, right? The direction of I is just a unit vector going to the right. It's just this one. Now that is I, right? Like that. So I need to calculate. So the answer is this angle here. like that, right? So I need to calculate this angle. So how do I do that? Well, I can calculate the angle alpha by just doing SOHCAHTOA. So doing that, if I just remove that minus for a second, right, then I can calculate that angle. That's going to be the opposite. That's going to be the adjacent. So I can do tan alpha is equal to 15/8, and that will give me that angle there. So I put it in my calculator. That's going to be the tan inverse of 15/8. And that gives us this angle there. So that's 61. Let me just write alpha is equal to 61.927, blah, blah, blah. So this angle, if I call this beta, by the way, the angle is what we're looking for. Beta is just going to equal 180 minus alpha, or 61.927, which is going to equal 180 minus answer is going to equal 118.07, blah, blah, blah. 118.07, blah, blah, blah. So that's the answer. They've given it to two significant figures in the mark scheme. So that's going to be 120 degrees, right? So that's the answer. Now, as well as that, there's also another answer as well. So it just depends on the perspective, and the mark scheme is not strict. So if we measure it anti-clockwise like that, then it would be beta. However, if we were to measure the angle with that the vector makes with the I component, right? Clockwise, then it would actually be this angle that we're looking for, isn't it? Like that, it would be that angle that we're looking for. And then that angle there, which I'll just call it what can I call it? What can I call it? I'll just call it, it doesn't really matter, call it K. Yeah. That angle, right, is literally just gonna be 360 minus beta, isn't it? Yeah. And that is if you're measuring it anti-clockwise. Yeah. So therefore it's gonna be 360 just minus that angle there, which is 241.1 what was it, point 1.9, sorry, blah blah blah. Marxi gives it to two, that's supposed to 240 degrees, right? So it's either equal to this one. So beta is 120 degrees if you measure it anti-clockwise. So anti-clockwise, or the other angle is 240 degrees if you're measuring it clockwise. So either one of these are fine. It's in the mark scheme. They're not lenient. They're not they are lenient, I should say. So yeah. Yeah, that's it. That is part B finished. Okay, so part C says the mass of P is m kilograms. Given that the magnitude of the acceleration of P is 8.5 meters per second, part C says find the value of m for 4 marks. Now, what we're looking for, m is the mass. They've given us the magnitude of the acceleration, which is 8.5. And throughout this whole question, guys, right, we've been dealing with resultant forces, right? We've been dealing with forces. So for me, that is just a clear indicator, right, that I need to use F equals ma, right? For sure. So how do I do that? Well, we know what the acceleration is. So I'm going to say F is equal to m times 8.5. Now, remember, mass is a scalar quantity, right? So I can't just plug in a vector because remember, the resultant force was given to us by, what was it? F1 plus F2, which is minus 8i plus 15j, yeah? So minus 8i plus 15j. Now, we can't just plug that into there because this is a scalar equation, right? So what we need to do is we need to find the magnitude of this resultant force here. And the indicator as well is that they've actually given me the magnitude of the acceleration. So that's just an indicator to do this, right? So we need to find the magnitude of that. So I'm going to do the magnitude of F like that is going to give me, or you know what I'll do just to make it nice. I'm going to call this R, which is the resultant force. And I'll call this the magnitude of R. So that's just going to be the square root of minus 8 all squared plus 15 squared, like that. And I'll put that in my calculator and see what I get. Let me just make this a bit neater, like that. And then that is going to be equal to square root of minus 8 squared plus 15 squared. And that is equal to 17. Like that. So the force here is going to be 17. So what I can now do is just say that 17 is going to equal m times 8.5. So therefore, that tells me that 17 over 8.5 is equal to m, right? And then that is just 2, isn't it? So put in the calculator just to confirm, 17 over 8.5 is 2. So therefore, m is equal to 2. So it's 2 kilograms. That is the mass of P. And yeah, that's it. That is this question finished. Okay, so question 11 says a particle P is moving on a smooth horizontal plane. At time t seconds, the position vector of P relative to a fixed point O is r meters and the velocity of P is v meters per second, where v is equal to 4t squared minus 5ti plus minus 10t minus 12j. When t equals 0, r equals 2i plus 6j. Part A says find r when t is equal to 2 for 4 marks. Okay, so variable acceleration vectors, right? Remember, we have displacement, then we've got velocity, then we've got acceleration. So I'll write like this now. I'll write for one variable, right? In terms of non-vectors, right? It's going to be s, v, and then a. When you go down this, you differentiate d dx, dy dx. And then when you go up this, you integrate. Yeah. And obviously it's the same when you're dealing with vectors. R, V, and A. Go down, differentiate, go up to integrate. So we're currently at V and we need R. So we need to go up one. So we need to integrate. So that tells me I need to integrate the velocity vector. So what I'm going to do is let me move it to the side. To be fair, you could just stop it and screenshot this if you ever want to use this, but I'm going to delete it actually. So we need to integrate that. So I'm going to say R then is going to equal the integral of the vector dt. And that just means that I'm going to be integrating 40 squared minus 5t I plus and then minus 10t minus 12j dt. Okay, now they've given us initial conditions, by the way, which we'll do in a sec. So integrating that is going to be r is equal to, that's going to be integrating term by term. T squared will integrate to t cubed divided by 3. There's a 4 there, so that's going to be 4 over 3 t cubed minus the t will integrate to t squared over 2. So that'll be minus 5t squared over 2. I'll put it like that. And then that will be I. And then plus, and then the j components, right? Minus 10t will integrate to minus 10t squared over 2. Minus 10t squared divided by 2. But 10 over 2 is 5, isn't it? So I can just write that as minus 5t squared. So minus 5t squared. And then minus 12 will integrate to minus 12t. And then that will be our j. And remember, we're going to have a constant of integration. Now, this constant of integration c is a vector. Now, how do we find that? Well, we use this initial conditions here. When t equals 0, r equals 2i plus 6j. So I'm going to put that in. So when t is equal to 0, r is equal to 2i plus 6j. So plugging that in is going to give me, r is, so no, I know what r is. R is 2i plus 6j. So 2i plus 6j, that's r on the left-hand side, is going to equal, you know what I'll do actually? Let me put this on top there. Let me move this to the left a bit. Like that. I prefer it like that. Put that colon there. Okay, yeah. So now that's the left-hand side r. And then now I'm going to plug in 0. Now, if I plug in 0 into all of these, right? 0, 0, 0, 0. They will just disappear, the i's and j's. So therefore, I could actually just say that 2i plus 6j is c. So now I've got the constant of integration, the vector here, 2i plus 6j. I can now say that r is going to equal all of this plus that vector, which we know to be 2i plus 6j. So like that. So that's going to be plus 2i plus 6j. 2i plus 6j. Now, what I'm going to do is I'm just going to write this neatly, right? So I'm going to say r is equal to, and then the i's can go there. So the 2, I will do it like this. So it's going to be 4 over 3 t cubed minus 5 over 2 t squared plus that 2, and that will be I, and then plus, and it'll be minus 5t squared minus 12t, and then that's the 6j. So I put the plus 6 inside there, and then j. And that is going to be our expression for r. Now, the question asks us to find r when t equals 2. So all that's left to do now is just plug in t equals 2 into the formula. So that will give us t equals 2. R will equal, then you just plug in 2 to all of that. So I'll do it. 4 over 3, 2 cubed minus 5 over 2, 2 squared plus 2, I, and then plus, and then minus 5, 2 squared, minus 12 lots of 2 plus 6, j. And then now it's just plugging this into a calculator and simplifying. So calculator, the first one is going to be, I'll do it there. That's going to be 4/3 and then 2 cubed, like that. minus 5 over 2, 2 squared, like that, plus 2. And that gives us 8/3. So R is going to equal 8/3 I. And then the next one is going to be minus 5 lots of 2 squared. Oops, I need to go to the answer. Minus 5 lots of 2 squared. Minus 12 times 2. That looks good. That looks good. Plus 6. And that is equal to minus 38. So that would be minus 38J. So your answer is R is equal to 8/3 I minus 38J. And that's it. That's part A finished. Okay, so part B says when t is equal to capital T, particle P is moving in the direction of the vector I minus 2j. Part B says find the value of capital T for 3 marks. Now, this is a classic question. They love these types of questions in the exam when they ask you about particle moving in a certain direction and they state the vector. Now, whenever you see this, right, if it's moving in the same direction as this vector here, I minus 2j, then it means that at the time capital T, the vector, the velocity vector is parallel to this one. So I'm going to say parallel, let me write V or a parallel. V is parallel to I minus 2j, right? At T equals capital T. Now, what does that actually mean geometrically and visually? So, for example, let's say I was to draw two vectors, right? Two parallel vectors. So let's say the vector 3i plus 4j, for example, right? That is the vector there. What would be a parallel vector? Well, you could just double the components, couldn't you? Just a multiple, right? Like this. Let's say it's 6i and 8j there, right? These are parallel. Now, the main thing is that the ratios have to be the same. The ratios of the components have to be the same. What I mean by that is this. If I write these as fractions, right? 4 over 3, and this one is 8 over 6. These are the exact same. And that makes sense because they're parallel. It's just a multiple of the other. So the ratios themselves are the same, right? Now, what we can do is use this idea to find two expressions for the ratios of the vector I minus 2j and the ratio of our velocity vector, and then equate them. And that way we can form an equation in terms of t and then solve it, right? So what I'm going to do is I'm going to move this over there, make this a bit smaller. Okay. So now I minus 2j. I minus 2j, that's going to look something like that. And it's always good to visualize these. I mean, you can do it from here, but I like to visualize these. So 1i minus 2j is going to look like that. That is our I minus 2j. And our vector v, right? If I was to do the same thing, at time capital T, it's moving in that same direction. So the I component of v, which is 4t squared minus 5t, like that. And this one is going to be minus 10t minus 12, like that. These have to be in the same ratio. So what we can say is that the minus 2 divided by 1 is going to equal minus 10t minus 12 over 4t squared minus 5t, isn't it? And in that way, we have an equation in terms of t that we can solve. And obviously, that value of t that we find is going to be capital T. So technically, you know what I should do, actually? I mean, I don't think you'll get penalized, but I'll put capital T's here for now. So 10 capital T, and then capital T. And then now we need to solve this equation here. So let's do that. So this looks a bit, let me make this a bit bigger actually. From this bar like that. And then let me make the minus a bit neater. Okay, so solving that, cross multiplying is going to give me, let me actually increase the ink actually. I think it's a bit thin. So yeah, that's better. So cross multiplying is going to be minus 2 and then 4t squared minus 5t. And that will equal, that's just the same thing, 1 times that. So minus 10t minus 12. Expanding that, that's going to give me minus 8t squared plus, that's going to be a 10t, isn't it? Like that. And that's going to equal minus 10t minus 12. And then move everything from right to left is going to give me minus 8t squared. That minus 10t will become a 10, it'll be 20t. And then that will become a plus 12, isn't it? Yeah, that'll become a plus 12. And that will equal 0. And then what we can do now is we can actually just let's times through by minus 1 first. So 8t squared minus 20t minus 12 is going to equal 0. And then let's divide through by 4. You could have done it in one go, but I'll just do it like this now. So divide through by 4 is going to give me 2t squared, like that, minus 5t. and then minus 3, and that will equal 0. Let me just double check. That looks good to me. Looks good. Yeah, looks good. Perfect. So now we need to solve this equation. Quadratic. Factorize. So factorize equals 3 equals 0. Sorry. I'm gonna put a 2t there and a 2t there. And then 2 times minus 3 is equal to minus 6. So I need two factors of minus 6, which will add to make a minus 5, which is going to be minus 6 and a positive 1, isn't it? Yeah, and then it will go there and there. And guys, let me know in the comments, is this how you factorize quadratics? Because normally what I used to do is obviously you split this in the middle, make that minus 6t plus a t, split down the middle, factorize the first two, factorize the last two. But one of my students, yeah, he showed me this method. I'd never seen it before in my life. So ever since then, I just use it. But yeah, let me know what method you use to factorize in the comments. But anyways, so now we're here. We look at each bracket, see if there's anything we can take out. We can take out a 2 here. So that will be a t minus 3, and then 2t plus 1 is equal to 0. And the actual factorization is you just cross that out. So that's the factorization. And then we solve. So that's going to be t equals 3. That's going to be 2t plus 1 is equal to 0. So 2t is going to equal minus 1. T is going to equal minus a half. Sorry. So now we've got two values for t. T is time though, so it can't be this one. So that's going to be wrong. So therefore t is equal to 3. And that is it. And that is it for this was part B, wasn't it? Yeah, perfect. This was part B. Now let's go to part C. So it says find the exact magnitude of the acceleration of P when t equals 2.5. So let me just grab everything there and see what we get. So okay. Okay. So we've done that. Now C. Doing this now. What we're gonna do. So we need the exact magnitude of the acceleration. We've got the velocity vector. So remember at the start of part A, we've got R, we've got R, we've got V, and we've got A. To go down, you differentiate. To go up, you integrate. So because we're at V and we need the acceleration, we need to differentiate this. So I'm gonna say A, which is gonna equal dv by dt, is just going to equal, differentiating that is gonna be 8t minus 5, and that will be our I, plus, and then our j is going to be just that will just be minus 10, isn't it? J. Now this is an expression for the acceleration vector, like that, and then minus 10 j. Now I want the exact magnitude of the acceleration p equals 2.5. So what I'm going to do is I'm going to find the acceleration vector at 2.5 and then take the magnitude. So I'm going to plug in t equals 2.5 into that. That will give me A is equal to 8 times 2.5 minus 5i. And then that's just minus 10j, to be honest, isn't it? So putting that into the calculator will give me 8 times 2.5 minus 5. That equals 15. So A is going to equal 15i minus 10j. So now to get the exact magnitude, right? That's what it asks for, the exact magnitude. We're just going to take the magnitude of this. So it's going to be 15 squared plus minus 10 squared, which is just equal to, put that into the calculator, 15 squared plus minus 10 squared. That equals 5 root 13. So the answer is going to be 5 root 13 meters per second. And that is it. That is the question finished. Okay, so question 12 says a uniform beam AB of weight 40 newtons and length 7 meters rests with end A on rough horizontal ground. The beam rests on a smooth horizontal peg at C with AC equal to 5 meters as shown in figure 5. The beam is inclined at an angle theta to the ground where sine theta is 3/5. The beam is modeled as a rod that lies in a vertical plane perpendicular to the peg. The normal reaction between the beam and the peg at C has magnitude P newtons. Using the model, part A says show that P is equal to 22.4 for 3 marks. Okay, so I've just got part A summarized here with the force diagram, everything that we need, right? So what you want to do firstly with these types of questions is obviously draw your force diagram. So we know that it's a uniform beam. The weight is 40, so it's going to act down the center. So I'm going to do a 40 newtons like that. That's the weight. What else do I know? I know that it rests with end A on rough horizontal ground. So it's going to be friction. Now, which way is it going? Because it's in equilibrium at the moment, right? If it was to drop, it would go down that way, which would mean that this would go that way. So friction would act to the right? Opposes motion. So friction is going to act that way. It's going to have reaction as well. So I'm going to call this RA like that. And then what else do we know? We know, let me wrap this up because it's not a force or anything. We know that there is a normal reaction to the beam at the peg at C, and this is P. So normal reaction is going to be perpendicular to the slope. So it's going to be like that there, like that. Perfect. And I think that is it. Now we need to show that P is equal to 22.4. Now, whenever you see these types of questions towards the end of the paper, right? It's typically a moments question, isn't it? So how could we show that P is equal to 22.4? We need to find an equation that we can form with P, right? So what I would do is take moments. And where will you take moments? Well, you always want to take moments about a point which will eliminate as many forces as possible, which is going to be at A, right? And that's typically the case with these types of questions. So I'm going to take moments about A. And remember, because it's in equilibrium, the anti-clockwise moments will equal the clockwise moments. That's how I always do it. So what I need to do is say, okay, well, what are the forces there? There's only two, to be fair. There's only P and 40, right? So with that being said, remember, a moment is equal to the force times the perpendicular distance. If I draw a right angle like this here, like that, then the perpendicular distance is just this 5 meters, isn't it? Right? And which way is that going? That is going, that is anti-clockwise, no? Yes, because clockwise is that way. Yeah, this anti-clockwise. So the moment of this force P is going to be literally P times by 5, right? That is going to be the moment, 5P, right? I'll leave it at that for now. And now the clockwise one, well, we've got this 40 newtons here. Now, what we need to do, what I like to do anyway, is let me extend this here like that. And the way I imagine it is that this vertical force going down is swinging this way to get to A, right? That is going to be clockwise. Now you just want to ask yourself, what is that perpendicular distance, right, to this vertical line? It's the base of this triangle, like that. So what is that distance there? Well, that's a right angle triangle. The whole uh beam AB, right, is 7 meters. This is in the middle, right? So it's going to be 7 over 2 or 3.5. So let me do it here. The hypotenuse is 3.5 of this right angle triangle here. Remember, this is adjacent. This side is adjacent. This is going to be 3.5 cos theta, isn't it? And obviously that one is opposite. That's going to be 3.5 sine theta, like that. Now remember, the moment is the force times the perpendicular distance. In this case, the force is 40 newtons. The perpendicular distance is that distance in green, which is 3.5 cos theta, like that. Okay, so with that being said, what is that? That is going to be 40. Let me do the right hand side. 40 times 3.5 is equal to 140. So 140 cos theta is going to equal 5p. Now we need to figure out what cos theta is. Now they did tell us that sine theta is 3/5. So just 3, 4, 5 triangle. Cos theta is going to equal 4/5, but let's just show you anyway. Got this there. We know that sine theta, all right here. Sine theta is equal to 3/5. So theta is like that. And then that's going to be the opposite, which is 3. The hypotenuse is going to be 5. That's going to be a 4 from Pythagoras. From Pythagoras. So therefore, cos theta, which we know is equal to the adjacent side, which is 4 divided by the hypotenuse, which is 5. That means that cos theta is 4/5. So therefore, we can say then that 5p is equal to 140 times by 4/5. And then we can just divide it by 5. So we work that out. So it's going to be 140 times by 4/5. That is equal to 112. So 5p is equal to 112. So therefore, p is equal to 112/5, which is equal to answer divided by 5, SD 22.4. And that's it. That's part A finished. Okay, so part B says find the magnitude of the resultant force acted on the beam at A, and this is a 6 marker. Now, guys, whenever you see this type of question, right, where they ask you to find the resultant force acting at a point, it's always just the Pythagoras of the vertical and horizontal component of the two forces acting at that point. So in this case, we've got I, which is the vertical force, and F, which is the horizontal force. So I'm just going to write here the resultant is just going to equal the magnitude of the resultant is going to equal the Pythagoras of RA squared plus F squared. So essentially what I need to do is just figure out what RA is, what F is, put it in Pythagoras, and we're done. Now this comes up a bit. It came up in 2019, the moments question in 2019, and it came up in 2023. I can't remember if it came up anywhere else, but this type of question, the magnitude of resultant forces, is something that you probably would have seen before. So how do I calculate those forces though? Remember, it's in equilibrium, right? Now I've got four forces in my picture. I've got RA, I've got F, I've got 40 newtons, and I've got P. Only one of them, right, is neither horizontal or vertical, and it's P. It's at an angle. So what I'd want to do is resolve this force P, right, into vertical and horizontal components, because that way I could just resolve vertically and horizontally, right? So what I'm going to do is if I draw a line like this, if I draw a line like that, and then I draw a line like that, then we know that immediately this angle is going to be theta, isn't it? Right? Which will mean that that one's going to be theta 2. And then that will allow me to resolve um, P, isn't it? So that's the adjacent. That's going to be P cos theta. This one's going to be P sine theta, is it? So let me write this out now because I know what this is in terms of its components, right? This one like that. This is going to be P sine theta, like that. Yeah? So now that we've resolved it, it's pretty easy to be fair. So let's resolve vertically to figure out what RA is. So resolving vertically, well, what forces are acting vertically? RA is, so is 40 newtons, that's going down, and we got P cos theta. So resolving vertically, we're going to say then that RA going up plus P cos theta also going up has to equal the 40 newtons going down. Now we know P and we know cos theta, don't we? P, let me write this out. RA is going to equal RA plus P is 22.4 and cos theta was 4/5, wasn't it? So I'll put that up there, is equal to 40. So therefore the reaction force is just going to equal 40 minus whatever that is, 22.4 times 4/5, like that. So putting that in, what do we get? Let's see. So it's going to be 40 minus 22.4 times 4/5. And that gives us 22.08. So RA is going to equal 22.08 newtons. Yeah, so RA is that. Now that we've got RA, let's figure out what F is. Now we're just going to do, we're just going to resolve horizontally now, right? So zooming out a little bit. Let me just zoom out a bit. So doing that one now. This force, F, right, is going to the right. This one is going to the left. These are the forces that we're going to equate, aren't we? So we're going to say then that horizontally, F is going to equal P sine theta. Now, again, we know what P is, we know what sine theta is. So F is literally going to equal P, which is 22.4, multiplied by 3/5, right? Because that's sine theta. So F is going to equal, put this into the calculator, 22.4 times by 3/5 is equal to 13.44. So now we've got everything we need. Remember, the question asks us to find the magnitude of the resultant force. Remember, it's just the Pythagoras of those two forces, which we now have. So we can now work this out. So putting that in is going to be equal to then the square root of 22.08 squared plus 13.44 squared. Like that. And this is equal to, putting this into the calculator, that is going to give us square root 22.08 squared plus 13.44 squared. That is equal to 24 root 29/5. 24 root 29/5. And that is going to be your answer. And yeah, that is it for part B, right? So that is done. Fantastic. And then part C, it says for 1 mark, hence show that the coefficient of friction between the beam and the ground is 14/23. Okay, this one is a 1 mark. I actually added it to the question actually because I thought it's just a nice 1 marker, you know, something they could ask and something that you should know how to do anyway. So coefficient of friction, mu. What is the formula? F is equal to mu r, right? So, right, part C here. We know that F is equal to mu R. Now, obviously, F is your frictional force and R is your reaction. Obviously, between the beam and the ground, the reaction is RA. F is equal to F, right? We know what both of these are from part B. We just literally put them into the formula, right? So let's rearrange first. Mu is going to equal F divided by R. Or let me put RA actually, because that's what we're using. So therefore, it's literally just going to be, what's that? F at the top, 13.44, divided by 22.08 at the bottom. And put that into the calculator. 13.44 over 22.08 is equal to 14/23. And that's it. Perfect. I'm sure if you got part B, I can't imagine you not getting C. But yeah, that's it. Done. Fantastic. Okay, so question 13 says a particle P is projected from a point O. The particle is projected with u meters per second at angle alpha above the horizontal. The particle moves freely under gravity. At the instant when the horizontal distance of P from O is x meters, P is y meters vertically above the level of O. Part A says show that y equals x tan alpha minus gx squared over 2u squared times 1 plus tan squared alpha for 6 marks. Now, what we're doing here, guys, this is just a classic case of deriving the Cartesian equation of a projectile. This specific questionnaire is in the Edexcel book, year 13 book. What else is there? From this, you can do many things, right? They can ask you to use trigonometric identities to show certain expressions. They can ask you to find a u. They can ask you to find the angle alpha and so on and so forth. But this here is your basis, so you definitely need to know how this works, right? And in the last couple of years, 2024, 2023, 2022, they've asked a variation of this in the sense where you have to use this and then they've asked you to maybe prove an identity, or even last year they actually asked you for a Cartesian equation. So here is the basis. If you can get this down, then you're really good to go. So how does it work? I've got this diagram here just to help visualize things, right? So we've got a particle P from a fixed point O, and it's projected with u at an angle alpha, and we know that at the instant when the horizontal distance of P from O is x meters, P is y meters. So what I'm going to do is I'm just going to actually just draw this here. And that, so let's just say we are here, right? Let's just say this distance is x here. And then at that same point, we are vertically above that point here. And this is y, like that. So what you want to do to show this is you actually just want to find expressions for your horizontal distance and your vertical distance, right? So let's go ahead and do this. Now, whenever I do projectiles, I always do this. Horizontally, right? Speed is constant, isn't it? Right? So what we're going to do is I always just say this. Distance, whatever the distance is equal to speed times the time. Like that. Okay, now what is the distance? We're saying the distance is x. Now remember, the speed is u at an angle. So remember, resolving like that, this is going to be u cos alpha, isn't it? You know, let me do it here so it's super clear actually. I'll do it here. So this is my angle here, alpha. This is u. This is going to be u cos alpha, the horizontal component of velocity, and this is going to be u sine alpha, the vertical component of it. So in case of the horizontal distance, it's going to be obviously the horizontal component of speed, which is going to be u cos alpha, like that, and we're going to times by the time, which we're going to call t. Yeah. So that here is done. So we've got an expression for distance, u cos alpha t. Now we want to do the same thing for the vertical, right? So I'm going to just write vertical here. Vertical. Okay. Now remember, we're moving through gravity, isn't it? So we have to use suvat here. So what I like to do is I'm going to say, well, what we're looking for, we're going to say uy, the initial component of speed, is going to be u sine alpha. If we model upwards as positive, actually, let me put that there. Upwards as positive, then the acceleration due to gravity is going to be minus g. What else are we going to say? We also know that this distance y, the distance vertically is going to be y. So I'm going to say s is equal to y. And what else? S equals ut plus half at squared. Yeah, t as well, of course. T is equal to t. It happens at the same time. Yeah. So what I'm going to do now is obviously, what is the formula? It's going to be s is equal to ut plus a half at squared, isn't it? So what does that become? Well, it's going to become y is equal to u, which is u sine alpha, and then t plus a half, and then a is minus g, and then t squared. So this is our equation here, and we've got that equation there. So let me get both of these and let's get to show that. Now, whenever you're doing these types of questions, guys, it's always the same thing. So let me get to show that as well, just so we can grab that and see where we need to get to. Okay, so we've got these two equations here, and we need to show that we get, where's the equation gone? It's over there. Where's the equation gone? Oh, there it is, right there. How did it get there? Anyways, we need to show that we get this right, and we've got these two. So what we need to do is eliminate that variable t, isn't it? Right? Now, how do we do that? It's the same thing with these questions. You're always going to use your equation for horizontal distance, right? You're going to use this and you're going to rearrange this. You're going to divide by u cos alpha. So you're going to get x over u cos alpha is equal to t. And then once you get this, you're going to plug this into there. Yeah. So I'm going to just call this, let's call this equation 1. I'm going to call that one equation 2. So we're going to literally sub equation 1 into 2. And that, what does that give us? So doing that, that is going to be, we're going to say it's going to be y is equal to u sine alpha times by t, which is going to be x over u cos alpha, x over u cos alpha, like that. And then plus a half, and then, you know what, I can just write minus a half g, can't I? So minus a half g, and then x over u cos alpha all squared, isn't it? And this is good because at least we've gotten rid of the variable t. Now we just need to show that we get this expression here. So how does that work? Let's have a look. Well, looking at what we've got here, you know what I'll do? Let me put this here. Put this here for now. All right. So looking at what I've got now, well, the u's cancel here, right? So I can say goodbye, goodbye. Sine over cosine from our trig identities, we should know is tan, right? So that becomes a tan, doesn't it? So that means we have y is equal to sine over cosine is tan, and we've got x. So that we get the x tan alpha there. So that's brilliant. Now it's just a matter of showing that we get that for the other one. So what do we do? Well, I've got minus a half g. I can square that fraction. It's just going to literally become x squared over u squared cos squared alpha, like that. And now what are we going to do? So if I isolate these here, and by the way, there's lowercase u in the question. I've got capital U, but it's the same thing. It's fine. I'm going to grab all of this here, grab all of this here, grab all of this there, like that. We can combine these, can't we? Right? That there is literally just going to become minus. It's literally going to become, what do we have on the top? We've got 1 times g times x squared. That's going to be a gx squared on the numerator. And then we've got 2 u squared on the bottom, 2u squared, right? Which is exactly what they've got there. Yeah. And then now we're going to times by 1 over cos squared alpha, like that. And then let me just write y is equal to x tan alpha. Okay. So this is where we're at, right? We're very, very close. Now we just need to show that that is that. Right, and that is fantastic. That's fine because remember from trig identities, we know that 1 over cos squared alpha is equal to sec squared alpha, right? And from our Pythagorean identities, this is 1 plus tan squared. So therefore, we can say then that y is just going to equal x tan alpha minus gx squared over 2u squared, like that. And then we're going to times by 1 over cos squared, which we know is sec squared, which we know is 1 plus tan squared alpha. And that is it. That is it. Done. Fantastic. And yeah, this is super, super important because, as I said before, in the last couple of years, 2024, 2023, 2022, they've asked a question where you have to use this, right? And it's given in different variations. So they could even actually just ask this one as well. So we'll see. It's also in the specification as well. So make sure you've got this down. But yeah, that's it. That's part A finished. Okay, so part B says a small ball is projected from a fixed point A with speed u meters per second at angle theta above the horizontal. The point B is on horizontal ground and is vertically below the point A, with A be equal to 20 meters. The ball hits the ground at the point C, where BC is 30 meters, as shown in figure 4. So we've got the diagram there. The speed of the ball immediately before it hits the ground is 25 meters per second. The motion of the ball is modeled as that of a particle moving freely under gravity. Part B says show that U is equal to the root of 233 for 3 marks. Okay, so this one here, we're looking for U, right? Which is going to be the magnitude of our initial velocity. So what we're going to do is we've got this information about the speed when it hits the ground. It's 25 meters per second. Now remember, this is going to have components, isn't it? If I was to just do that there and then that there, like that, then this would be our x, our horizontal component of the velocity, and that would be our vertical one, right? Now, what we're saying here is that the magnitude of this is 25. So what I can actually say is that the square root of x squared plus y squared is equal to 25, right? That is a fact. Now, what we need to do is figure out what x and y are. Now, remember, we're modeling this initially from the point A. So that x, which is going to be the horizontal component of velocity, remains the same. It's going to be u cos theta, isn't it? So I'm going to just say here, the x is going to equal u cos theta, like that. And then, well, what would y be? Well, remember, vertical component of velocity, we're moving through the air. We have to use subat for that. So what I'm going to do is I'm going to say y is going to equal vy, right? And we're going to use subat to figure out what that expression for y would be. And then we could plug it into here and then solve, right? So let us do that there. So I'm going to just say again, vertically. So what do we know initially when we're dealing vertically? We know that the vertical component of velocity is u sine theta. We know that A is equal to minus G. And what else do we know? We know that Vy, right, is equal to Y, right? That's what we're trying to figure out. V squared U squared 2AS. And obviously, S, the displacement, right, is going to be minus 20. So I get that there, right? So what I can do is use a subat formula that connects all of these. V, U, A, and S, V squared equals U squared plus 2AS. Like that there. And then now I can say, well, Vy, which is going to be Y squared. So it's going to be Y squared is going to equal U squared, which is U. I'll do it like this just to be super clear. U sine theta all squared plus 2, and then A is minus G, S is minus 20. Like that. So therefore I get this. So I have Y squared is equal to U squared sine squared theta. 2 negatives will cancel. 2 times 20 is 40. This is 40g. Like that. So now I have an expression for y, don't I? Or I can square root. But the main thing though is we're using this formula here, right? So essentially, let me grab these because I actually don't need to square root it, do I? So let me grab this here. And then remember, at the end of the day, we're trying to figure out what u is, right? We have expressions for x and y, which are both in terms of u, isn't it? So if x is u cos theta, that means obviously x squared is going to be u squared cos squared theta. And then obviously now I could put that in there. Let me write this one more time. U squared sine theta squared plus 40g. I can plug this into this formula here. Remember, we're trying to show that u is equal to the square root of 233. So, yeah, plug it in everything. It's going to be, to be fair, you know what I'll do actually? I'm going to square both sides first, right? Because I don't need to write the root. If I square both sides like that, then I'm just going to have x squared plus y squared is going to equal 25 squared, isn't it? And then now I'm going to plug those in. So it's going to be u squared cos squared theta plus y squared, which is going to be u squared sine squared theta plus 40g. And that is going to equal 25 squared, isn't it? Now, remember, we're trying to find out what u is. Immediately, trig identities. Remember, even though pure is done, it's still not done. That is just cos squared plus chi squared, which is 1. So if I take out a u squared, I'm going to have cos squared plus sine squared in the bracket. And then if I move that over, it's going to be 25 squared, take 40g. Now, that there is just 1, isn't it? U squared, this is 1. That's 1. So that is just going to be u squared times 1, which is u squared. And then that I'll put in my calculator. Already done it. 25 squared minus 40 times 9.8 is 233. So 233 there. So therefore, u is equal to root 233. And that is it. And that is our part B. Truthfully, this is actually from an international paper, and it actually didn't ask you to do it this way. It's actually a further maths question, and you had to use the conservation of mechanical energy. So you could have done it that way, further maths students. So I think what I will do is I will just do it that way. It won't take long in the next section, and then yeah. we'll finish. But yeah, that's the main way to do it. So what I wanted to do with this one is obviously because it's a walkthrough for A-level maths, I thought may as well do it with Suvat, right? Because yeah, why not? Because you can, right? So it's a perfectly legitimate question that you could use Suvat for. So yeah, I'll do the further maths method in a sec. Okay, so the further maths method, yeah, the question actually did say use the principle of conservation of mechanical energy in the actual question, but I did tweak it, so I thought I should definitely do it that way. But yeah, uh, conservation of mechanical energy states that the kinetic and potential energy before motion is the same after. So remember, we're going from A to C. So the kinetic energy there, remember the formula is just a half m v squared, or the speed squared. So in this case, it's going to be equal to a half m, and then u is the speed in this case, so u squared. The potential energy is just mgh, so it's going to be mg times the height, which is 20, isn't it? That is before, and we're saying that the energy here is the same, right? The potential energy is going to be 0 because we're underground, there's no height. The kinetic energy, luckily they gave us the speed to be 25, so we can have a half m and then 25 all squared. And then now obviously because these are the same, we can equate them and get an equation in terms of u to solve. So I'll do that. Let me just zoom out a little bit. So it's going to be I'll do it here. It's going to be a half m u squared plus the 20 mg. This will equal the potential energy and kinetic energy at the end, which is just going to be a half m 25 squared, like that. And obviously we've got an equation in U that we can solve because the m's cancel. So cancel, cancel, cancel. What else do we have here? If I times by 2, then I'm going to have a u squared plus, that will be a 40g, and that will equal 25 squared, like that. And then obviously u squared is going to equal 25 squared minus 40g, which is what we got before, isn't it? But yeah, I'll just do it again anyway. 25 squared minus 40 times 9.8 is equal to 233. So yeah, this is actually quicker, isn't it? But yeah, I thought to do it the other way because it's still a good question. You still can use just standard A-level math methods to do it. So I thought to do it. Maybe I should have given an extra mark. But yeah. So that's pretty much it. To be fair, I haven't actually done further. I haven't taught further in about 5 or 6 years. So yeah, I still remember bits and bobs though. So maybe I'll do some further maths over the summer and do some content on it. But yeah, that's it. Finished. Okay, so part C says we need to find the value of theta, the initial angle of projection. So remember with these questions, right? These are all sequential. What did we do in part A? Remember, we derived this Cartesian formula for the vertical height. Now remember, this formula is powerful, as I said before, because it just models the height of any projectile, right? This is a general formula. Because we've got a projectile problem right here, we can actually use this and use the values that we have and plug them into the formula. So what I'm going to do is I'm just going to grab this. I'm going to grab this formula here. And then with our model, technically, we've got the angle theta, isn't it? And then the initial speed is capital U instead of lowercase u. So I'm just going to rewrite it, even though it's really not that deep. But anyways, it's going to be y is equal to x tan. Instead of alpha, I'm going to use theta. And then minus g x squared over 2, and then obviously u is capital, isn't it? So capital U squared, and then 1 plus tan squared, and then again replacing alpha with theta, right? Now what we have here is the general formula for this one, right? What do we know though? Remember, we know that the vertical height is 20, right? And the horizontal distance is 30, right? So we can plug those in. Now remember, upwards is positive. So what I'm going to do now is I'm going to just say y is going to equal minus 20, right? Because we're down there. And then x is going to equal 30. And obviously we know that u is equal to root 233. So we can plug these all into there to figure out what the angle theta must be. So doing that, that will give us minus 20 is going to equal x, which is 30, tan theta, minus g, and then 30 squared, over 2, and then u squared. If u is the square root of 233, that means that u squared is just 233, isn't it? So I can put that there, and then times by 1 plus tan squared theta, like that. And then now, this is just a quadratic in tan, so we can just tidy up, can't we? So what I'm going to do is I'm going to put this into my calculator to figure out what this is and then expand it. Yeah. So I'm going to put this in. It's going to be G is 9.8. We get a fraction going. 233 on the bottom, and then it's times by 30 squared, which is 900, but I'll always write like that anyway. So that's fine. I get that there. That's going to be minus 4410 over 233. Let me just double check. Yep, that's good. And then 1 plus tan squared theta, like that. And then I've got minus 20 is equal to 30 tan theta. Like that. Okay, now what I'm going to do is I'm going to expand the brackets, right? I'm going to just make it a nice quadratic. So it's going to be minus 20 is equal to 30 tan theta minus 4410 over 233 if I expand it with the 1, and then minus 4410 over 233 tan squared theta. Now, move everything from right to left. So this term is going to be positive. So it's going to be 4410 over 233 tan squared theta. And then it's going to be that 30 tan theta will be a minus on that side. Like that. And then now this is going to go over there, isn't it? That will go there. So it's going to be a minus 20 still. And I'm going to add on that 4410 over 233. And that's going to equal 0, isn't it? So we're here now. And then what is that equal to? Plugging that in. I've already got that there. I just need to take 20 away from that to get that, don't I? So I'm going to do answer take away 20. That'll give me that there. So it'll be minus 250 over 233. Just double check. Yeah, that's good. And then minus 30 tan theta. And then 4410 over 233 tan squared theta. Tan squared theta is equal to 0. Perfect. So we're here now. We've got a quadratic. And all we need to do, let me just write this a bit neatly. So that is going to be tan squared theta, isn't it? Let me try it a bit neatly. Tan squared theta. And all I need to do now is just solve this. So I'm going to put this in my quadratic solver and see what I get for tan theta. So tan theta is going to equal, let's see what we get. So doing that, quadratic solver. Let me just move this to the side a bit. Okay, perfect. All right. So I'm going to go to menu. I'm going to go to equation 2. 2, polynomial 2, coefficient is 4410 over 233. Middle one is minus 30. Last one is minus 250 over 233. And I get that there. And I get that value there. So tan theta is going to either equal 1.620, blah, blah, blah. Or tan theta is going to equal minus 0.034, blah, blah, blah. Now, remember what we're trying to calculate theta, the angle of projection. Remember, that must mean that the angle is going to be acute. It's going to be between 0 and 90. So solving both of those, it's obviously going to be the one on the left, but getting those in here. What answers do I have stored? Okay. Yeah, tan theta, the tan inverse of that number, which was 1.620 approximately, that was that there. So that's going to be 58.3 degrees. And then obviously if I add 180, it's going to be away from it and take away. So it's either going to be that or the other one. So what was it? It's going to be, tan inverse of minus 0.034. And that is equal to small angle. So theta is equal to minus, let me just double check I put it incorrectly. Yeah, that's fine. Minus 1.94, blah, blah, blah. Right? So which one is it going to be? It's obviously going to be this one. Yeah. So you're just going to say theta equals 58.3 degrees as theta must be between 0 and 90. And that's it. And that is question finished. And that is the paper finished. Oh my days. I'm so excited. I'm done. I'm done. I'm done. I can sleep. Hey guys, Daniel here. So yeah, that's it. That is the paper finished. And wow, guys, I'm so happy to say that. As you can imagine, it takes a lot of time, but this is my 9th walkthrough of the exam season. I've done 6 for GCSE, higher and foundation. and now this is my third one for A level. So yeah, I'm happy to have it done now. And yeah, more importantly though, I'm hoping that this video was helpful. I hope the paper was okay, and I'm hoping that this walkthrough has clarified things and made you understand things a bit better. Anything that you found a bit tricky, and more importantly, I hope that you guys are in a better position and you feel more confident for your exam on the 19th. But yeah, I'm sure you guys are going to do very, very well. Anything I need to add? Yeah, guys, good luck. Good luck. I'm sure you guys are going to do very, very well, in a sense where you guys are always commenting on my videos. You guys are asking questions, which is good to see. You guys are studying very, very hard. So yeah, this is pretty much, I think, majority of your lot, or majority of you, this is going to be your last exam. I think some of you guys may have chem the day after, or bio. I can't remember which one it is, but it's one of them. But yeah, hopefully you guys do very, very well. I'm sure of that. And yeah, guys, if you found this video helpful, as always, it would be great if you like, comment, and subscribe. Share with your friends, share with anyone that you think will find these videos helpful. But yeah, guys, good luck for Thursday. Do let me know how it goes. I'm sure it will go amazingly well for every single one of you. But yeah, until then, take care, and I'll see you guys soon. Bye bye.